Hello, hello, everybody. Hey, there we go. Nice. Welcome to the SF Ruby meetup for May. We're going to get started. We have a super busy program today. So if you could all gather, well, not gather, I guess wherever you want to sit is fine. There's lots of seating outside and inside. Our wonderful AV wizard, Ronan's helping us get set up with pretty much the top-notch AV setup I think we've ever had for this meetup. Yeah, big round of applause for Ronan, please. And a big round of applause for Cisco Meraki for hosting us today. Yeah, awesome. All right, so like I said, we have a hugely packed program today, more stuff to fit in than we have had before, and that was kind of on purpose, kind of on accident. So, yeah, bear with us. We'll get started here. We'll get through all this content, this awesome Ruby goodness that we have planned for all of you today. So at 5:40, our first talk is from Fito, Von Zastrow and Alan from Cisco Meraki. We'll also have some words from Ronan about Cisco. Obie Fernandez at 6 o'clock. Todd, how do you pronounce your last name? Kummer, Todd Kummer, deploying a hobby project on Rails 8 at Kamal. A break, and then we'll do open mic. Open mic is just a time for you to come up and talk about whatever you'd like for a minute or so. Keep it tight, please. Someone from Even Martians, Victoria, about Ruby events not to miss in 2025. That's this year, in case you were wondering. And then our last talk of the evening, Brendan Weaver recapping his his RubyConf keynote, read in Fantasyland, and then we'll wrap up. A couple other quick announcements. Don't forget that we do have an SF Ruby Slack channel or Slack account channel. I don't know what you call that. Account, I suppose, workspace. That's what it's called, a workspace. Scan that QR code, hop into the Slack channel. Sorry, Slack workspace. Camera, we just covered this. What's wrong with you? Excellent. I'll leave that up for a minute or so. Take a picture or scan that. All right, I don't see any more. I see two more phones in the back.
1 sec.
No problem. No problem. You're just making us all wait. That's fine. We'll just hang out.
I'm in.
Just kidding. All right. Also, quick note that this event is sponsored by Ruby Central. Big applause for Ruby Central, please. As you may know, Ruby Central is the organizers of the RubyConf and RailsConf flagship conferences in North America. They're also big maintainers of open source, Ruby Gems Bundler. Consider donating to them as an individual, or maybe get your company to do so if you feel so inclined. They sponsor local events. You can learn more at rubycentral.org. We're also promoting/sponsored by Fastly. So I think all of us know about Fastly, but just if you don't, it's a really nice, awesome CDN. And also they also support Ruby Gems and Bundler, and they have a new partnership with Ruby Central. So thank you, Fastly. Okay, I'm gonna hand the mic to Ronan. He's gonna talk to us a little bit about Cisco Meraki.
Thank you so much for coming to our edition of May of Ruby Meetups. Thank you, Irina, for asking Meraki again to host. That's the second time Cisco Meraki is hosting the Ruby Meetup of San Francisco. This time around, Amy over there sponsored our meetup. She's recruiting at Meraki. And so if you want to have a job at Meraki, you can talk to her. She also brought a lot of socks that are super comfy. So if you want socks, they're over there. Don't hesitate. But anyway, why would you like to work at Meraki? So Alan here is going to present, and usually he says we are the biggest Rails application in the world. It's one of the probably we have a lot of line of code because most of the business of Meraki is written in Ruby and Rails. It was one of the first Rails application out there. And yeah, so here's a little bit of a of a story of Meraki. Meraki means something done with soul and creativity and love. And that's what Meraki has been doing for many years now. It's born from like a research project at MIT. They wanted to bring like internet to everybody for free, and then like they realized that like what they were building is actually like really good gear, and so Cisco bought them for that. We are a bit over the world, all over the world, but this is just Meraki. We have like we are under Cisco or in Cisco, right? Cisco is absolutely everywhere in the world. What is Meraki magic really? You plug your device and it works. That's like what you want to have as an experience as a user. What we sell is like the awesome experience of creating your network really seamlessly. Basically, usually you would have to wait for your gear to come in and then like go in CLI or some dashboard and like connect with your phone or something once your gear is here, right? But with Meraki, you can just like close your sales call, and you have access to the dashboard. And then you can already like set up your network, set up your cameras, everything you want. And then when you receive your gear, you can just plug it and it works because it takes all the configuration from the Meraki dashboard. So that's really like what makes Meraki magic. Also, the dashboard is really incredibly thoughtful. It helps you like, even if you're like kind of like newer to like networking engineering, it helps you like secure your network and help you configure your network. So, and it's also beyond the network. We have like MT, which is like sensors. Thank you. Sensors for like everything, the door, the temperature, and you have like MV, which is video and like camera. And yeah, all the gears you want, really, 5G, switches, firewall, everything. So yeah, it's really exciting to work at Meraki for that. So here's like a little bit of our customers. We are like in the government, we are in big companies, we also like small companies. Our values, now we have like Cisco values, but like that's like the values, the original values of Meraki. Simplify everything, care deeply, everybody in, and be brave. Attack like the problems that we want to solve. So yeah, thank you so much for being here. Thank you for having the Ruby meetup, Irina. And yeah, enjoy the Ruby meetup.
Awesome. Thank you, Ronan. Thank you, Cisco. All right, our first talk of the day, of the evening, is Fito von Zastrow. I'm saying that right? Okay. And Alan Ridlehoover. Come on up, guys.
First try.
I've heard it before.
Hi there. First things first, we were supposed to start at 5:40. It's 5:46. And we have a 30-minute preview of our RailsConf talk that was apparently supposed to be 20 minutes. So we're going to rush through this as quickly as we can. So welcome. Thank you for coming. Got to keep this in my mouth. My name is Alan Ridlehoover, like Cameron said. My pronouns are he, him, and I lead platform engineering here at Cisco Meraki. And Ronan almost got this right. We are probably the largest rail shop you've never heard of, except somehow you managed to all find your way here.
Hello, testing. All right, cool. My name is Fito von Zastrow. I also use the pronouns he, him, and I'm a staff software engineer here at Cisco Meraki in one of Alan's teams. I'm focused on the modularization of our main Rails monolith. Now, before we get started, like Alan mentioned, this is a preview of a talk we're going to give at RailsConf. It's only the second time we're doing it in public. So we hope you like it, and if you have feedback, please send it our way. At the end, we'll have our contact information on the screen. All right, Alan, you want to kick us off?
Yeah. All right, so we call this talk Derailing Our Application, but that's not about moving off of Rails. We are not moving off of Rails. Rather, we want to share how and why we're decoupling ourselves from Rails constructs. So let's start with why in the world would you want to do that? I'm going to go back in time here. In the beginning, Rails 1 shipped in 2005, December of 2005. Work began on our monolith in April of 2006 on Rails 1.0. At that point, people were still writing fat controllers. No one knew the Rails way. We hadn't yet lived through the Ruby 1.9 or Rails 2.0 upgrades. There were no RESTful routes. You couldn't chain active record queries. And you had to do dependency management manually because bundler didn't exist. Plus, we weren't well-grounded, eloquent, or practical. But that didn't stop Cisco from acquiring Meraki in December of 2012 because they recognized that Meraki was innovating incredibly fast. And that's despite the fact that the central concepts of our application were written long before any of those best practices were established. This is not an actual class diagram, but it's not far off. Now, at that point, there were fewer than 40 engineers. The app was about 3,400 files, and it was close to 250,000 lines of code. 7 years later, when Fito and I joined, there were around 200 engineers, close to 9,500 files, and nearly 1 million lines of Ruby code. That growth has not slowed down. Today, we have about 1,000 active contributors to the code base. There are nearly 60,000 files and about 4.2 million lines of Ruby code. Now, as you might imagine, with a code base this large, whose central concepts were laid down almost 20 years ago, well before Rails best practices were a thing, there is some pretty complex stuff going on in there. You might even describe some areas as a bit of a mess. But according to Sandy Metz, in her post entitled The Half-Life of Code, most applications are a mess. And having a big mess may actually be a sign of success because it's certainly a sign that your application has survived a constant barrage of new requirements added under urgent time pressure, which tends to drive applications toward disorder. And as entropy increases, velocity gradually slows. And that is the tragedy of many successful software applications. To become successful, you needed to add as much functionality as you could as quickly as possible. There was little or no time to pay down tech debt. And over time, it became harder and harder to add new features. That sounds pretty bad, but let me tell you, it's a whole lot better than the tragedy of unsuccessful software. So we're happy to have this problem, and that's why we're derailing our application, because of all those things. So, Fito, what does that mean?
Well, I'm glad you asked. Like you said, it is not moving off of Rails. But in order to fully answer this question, let's talk a little bit, just for a minute, about software architecture. So the way we think about it, software architecture is about how we organize our code to promote the qualities that we desire in our system. So Rails, for example, uses its architecture, the way it organizes the code, to promote rapid onboarding through convention over configuration, and to promote separation of concerns by embracing the MVC pattern, and to promote testing by including things like request specs in the framework. All of those are great. And all of that worked really well for us, up until about right here. Now, at some point between 250,000 lines of code and 1 million lines of code, Rails' architecture alone was no longer enough. The application just, as it grew, it gradually became harder to figure out where you make your changes. Testing those changes became harder the more code there was to go through. It just became incredibly difficult. And both of those things, aside from slowing down development, they were causing onboarding to slow down. Now, there was evidence of this when Alan and I joined. Onboarding was expected to take around 9 months. So that's the time before you were fully productive in the code base. The code also seemed to gravitate towards the central concept of the app, even when the code wasn't related. Where do you put this? Well, most of the code is here. Let me just put it there. And the test coverage was very low. It was below 50% at that point. Now, you might be wondering why. Why was it in that state? Well, because, like Alan mentioned, our application was under a constant barrage of new requirements that needed to be completed, often under urgent time pressure. And then somewhere around here, Cisco announced that the Meraki dashboard will become the cloud management platform for all of Cisco devices. Now, that meant that we needed to onboard hundreds of Cisco engineers, many of whom knew very little Rails or even Ruby. And they would need to know where to add their code, how to test it easily, and get productive quickly. So we needed to speed up onboarding. We needed it to be more obvious where code should go, and we needed to make testing less cumbersome. But how do you do that to a giant Rails app? Alan, you want to explain?
Sure. So we knew we wanted to solve these three problems, and we started thinking about how can we do that? What attributes can we instill into our code base that might help us with that? And how might we organize our code base to instill those properties in it? So we came up with 4 attributes we wanted to instill. First, we wanted to make our code as clear as possible. In other words, we wanted it to be easy to read and easy to change. This clarity definitely helps with onboarding. It can also help with just knowing where to put code. Second, we wanted to give teams autonomy to allow them to experiment in isolation so they wouldn't need to gain consensus across the organization to make a change, or so that they wouldn't impose their solution on everyone else. Third, we wanted to promote accountability so that we would know who to talk to when a particular test file's coverage sank, or when the flaky test was discovered. And then finally, we wanted our code to be more testable because well-tested code is easier to understand, easier to change, and more reliable. Next, we needed to think about, well, how are we going to instill those qualities in our code base? In what ways could we reorganize our code to support these qualities? And we chose 2 approaches that are not Rails approaches. The first is modularity, and the second is boundaries. Now, by modularity, what I mean is breaking large things into small things. And modularity is going to help us support clarity and testability. Boundaries are the walls within a code base that enable the autonomy and accountability. Boundaries reduce the cognitive load across the entire engineering organization because you no longer need to know about all 4 million lines of code. Instead, you can focus only on the code your team owns. Okay, so we figured out what problems we needed to solve. We wanted to speed things up for onboarding. We wanted to make it obvious where code belongs. We wanted to simplify testing. From there, we decided which attributes we needed to instill, including clarity, autonomy, accountability, and testability. And then finally, we chose a couple of different strategies to reorganize our code in support of those attributes, modularity and boundaries. But will it blend? Fito, can you show us some examples?
Yes, let's do it. All right, we're gonna take a look at some examples of how we are organizing code in our controllers, views, and models. Now, the code in these examples is made up. It is not our production code, but it was inspired by real production code. So instead of networking concepts, you're gonna see concepts related to coffee machines. All right, so the first thing we decided to do was to remove the business logic that was hiding in our controllers. We started there for a couple of reasons. Our business logic is the most valuable code we have. That makes sense, right? It's what differentiates us from our competitors. It's also where developers spend most of their time adding features, fixing bugs. So it's where we get the biggest return on investment from having high test coverage. But controllers can be really difficult to test. And so that's another reason to start there. They often require complex setups in order to exercise every code path in a controller action. So, the more logic you have there, the more cumbersome testing becomes, and eventually people just stop writing these tests and they opt instead for manual testing, which feels easier, but it's actually slower and you can miss things. So we restructured our code to make it easier to test via simpler, quicker unit tests that require less setup. They need to know less about the world. Let's take a look at an example. Okay. Don't worry if you can't read it. That's on purpose. So this is a controller that handles requests to update the settings of multiple coffee machines that belong to a cafe. Now, like I said, don't feel like you need to understand this code. I want you to focus instead on the variety of colors on the screen and the shape of the code. Both are indicators that there are lots of different things going on in there. Let me walk you through some of the high-level things. First, there's an active record transaction there, and then there is a loop right inside the transaction. And it's looping over an array of arrays that contains a coffee maker ID and the corresponding changes to that machine's configuration. Now, inside this loop is where most of the business logic lives. The code is doing things like validating input, populating errors, serializing a hash of changes, and then finally saving the settings. And then back outside the loop, there is a bit more business logic. It's creating some sort of cafe event, probably for some notification system. And then finally, there's some aggressive exception handling because the code is scary. Anything could go wrong, right? So there's an ensure block there in charge of rendering the response. Now, like I said, there's a lot going on here. We don't have to solve all the problems at once, though. In fact, our approach has been to first focus on a smaller chunk. And in this case, we're going to focus on the body of the loop. Now, before we do anything to that code, it is important you always ensure you have at least a high-level test that will tell you if you completely break this. Obviously, if we had full coverage, we wouldn't be doing this. But you need to have at least one test. Let's assume we have that, and let's take a look at how we extracted this. All right, so here we just pulled out a class called update water tank settings. This class encapsulates the procedure inside the loop, and is now only concerned with a single coffee maker. Now, this makes testing the logic much easier since you no longer have to think about HTTP requests, or is the user logged in or not, or the HTTP responses. But you also don't have to think about the loop. You can focus on the effects this class has on the settings of a single coffee machine. And as a bonus, it turns out that this procedure was primarily concerned with settings related to water tanks, like a coffee machine's water tank. And extracting this class gave us that opportunity to give it a more descriptive name. This will make it easier for new folks to find that code now. There's still a lot of logic left in the controller, so the next step is to extract that code. Here we created a new class called update coffee machine settings and moved the rest of the business logic there. Now the controller looks a whole lot more like your traditional scaffolded controller. It's only responsible for handling HTTP requests and sending back the response. It collaborates, though, with this new class that is in charge of building the response. Now, the new class, on the other hand, still has several responsibilities, more than we'd like to see there. But we're going to defer that to the next person that touches this file. Our goal here was just to make it easier to test, and we've accomplished that. So the next time somebody's touching this, they can further refactor it. Now, extracting business logic out of the controller helped us with clarity and testability. The fewer things you have to keep in your head and easier to test. But in order to promote autonomy and accountability, we really need some kind of boundary. So we started with all the code in the controllers directory. And now that we've extracted a class, we have the ability to move that code. And we can put it in a different directory. So here we introduce a domain directory. That's just a name we picked. You don't have to pick domain. In fact, in a real code base, we use a different one. But it's somewhere else to organize your code that's not in Rails constructs. And we put a coffee machine subdirectory, and we move the classes in there. Now, this directory structure gives you a namespace where you can put all the business logic that's related to coffee machines. It makes finding the code related to coffee machines much easier, which also helps with onboarding. It also allows the team that's in charge of coffee machines to take ownership, to experiment with different approaches without requiring consensus from the entire organization, and also to be accountable for the level of test coverage, flakiness, or complexity in their directory. Now, another benefit of this structure is that it allows us to use the namespace to convey some information. I'll cut it short because we are in a tighter time frame here. So, Alan, show us what we did next.
All right. So the next thing we did was we looked at our views and we thought, well, there shouldn't be any business logic there. We specifically looked at ERB files, but these present a different challenge. First, ERB files can't be processed by sort of the community standard code quality tools like SimpleCov or Flog. They just won't process those files. So, plus, view tests are difficult to write and can actually produce false positives due to the fact that you have to create the instance variable that the controller would ordinarily set, and now you're setting it in the test. So if your controller changes and somehow changes how it's setting that thing, or maybe quits using it, you've got a test that's going to continue to pass even though it doesn't tell you what's actually happening. So the embedded Ruby syntax is also a lot harder to read than just plain old Ruby. So we've restructured our views to make the code easier to test and easier to understand. As a bonus, we can now measure the code quality. So here on the left side, we have a controller that's in charge of rendering configuration properties for a coffee machine. These are coffee machines that are on the network. You can send config to them. The controller itself is not doing much. It's just finding the coffee machine, setting a couple of instance variables, and rendering a template. Now on the right, we have the view, or the ERB template. Now, this template contains business logic that decides which properties get rendered under what conditions. The output of this file is a text file with key value pairs separated by new line characters. Looks like this. So looking at this response, we realized, why are we doing this in ERB? We don't need it. But let's just create a plain old Ruby object. That should be enough. And so, again, before we refactor this kind of thing, we want to start with tests. We're skipping over that here for brevity, but we would make sure that we had a high-level test here and that it was passing before we did this. So going back a step, here's the controller and the ERB template as we left them. Let's replace that ERB template with a PORO. All right, so this new class is called Coffee Machine Configuration. It encapsulates the business logic that was in charge of building the configuration properties. And we've also pulled in the code that calculated the instance variables that were in the controller into this new class. Now, the reason for that is that the variables were deeply embedded in the views logic, and the controller had no use for them other than setting them so that the view could access them. We did leave the coffee machine, the setting of the coffee machine variable in the controller, because the controller does use that to determine what the correct HTTP response should be. For example, we don't need to instantiate this new class if there is no coffee machine found. All right, so the benefits of this extraction are that the coffee machine configuration class can now be tested as opposed to the ERB template. We can get coverage and complexity information out of this new class, and the controller is also much easier to test since it's responsible for less business logic. All right, let's look at where this code should go. So we started with code in the controllers and views. We replaced the view with a pure Ruby object. We put it in new coffee machine configuration class in the domain coffee machine directory and rename it to just configuration since it's now the only coffee machine. Now it's in the coffee machine namespace. So what's next, Fito?
All right. You'll hear me? Yeah. All right, so next we moved business logics out of our models. And I want to acknowledge that this might seem unnecessary or counterintuitive for some folks, given that skinny controllers and fat models is considered a best practice in the Rails community. However, we have a few reasons to do this. Most of our models represent those core concepts in our application, and that makes them magnets for code. So the more code gets added to these models, the lower the cohesion of the code within the model, and the higher the chance that the methods, all these methods that you have in there that are now less and less related to each other, start to be implicitly dependent on each other. They get coupled, making it extremely hard to change. So to summarize that, models just become these junk drawers that, aside from the code being hard to change, it makes it really hard to draw boundaries around it and to figure out what code belongs to what domain or what team. Plus, putting business logic in active record lifecycle hooks or scopes makes them a little bit more difficult to test without actually involving the database. All right, On the left, we have here a controller action that's in charge of broadcasting details about a coffee machine to a network. Now, the controller queries the database to find the correct coffee machine and then calls the broadcast details method on the coffee machine model. Now, on the right, we have the model. You can see the broadcast details method there. It just builds a string that contains various details about the state of the machine. Now, same caveats. Let's make sure we have tests before we do any of this. Let's assume we have that. And here is the extracted version. We've taken the logic from that method out into a new class called coffee machine broadcast details. Now, this class now receives a coffee machine and performs the same logic to build the same string. But this new class has a few advantages. First, it is no longer implicitly coupled to the attributes or private methods or instance variables in the model, making it more extensible. As long as it receives an object that responds to the same methods, it can be used in other contexts. Like you can pass it an immutable struct instead of a model. Second, it's easier to test since the coffee machine object is now passing the initializer. You don't actually have to make even an active record object to test this. And finally, the code in the class, like I was saying, is no longer accessible to other methods in the same model. And so it provides more encapsulation, fewer chances that you're going to create this incidental coupling between methods. And the main benefit is that we can now move it inside a boundary. So we started with the code in a controller and a model. We extracted this out into a class. And now we can put the broadcast details class in the coffee machine directory. All right, that was a brief look at some examples of how we've extracted our code out of Rails concepts. To summarize our approach, though, that was probably not new for a lot of you. We're just putting business logic in plain Ruby, plain old Ruby objects, poros. Now we're moving those objects, though, into these namespaces that are creating a low friction boundary. Now, if we bring together all the classes that we extracted, the directory structure looks like this. Now, you might have noticed that these classes here are not organized by patterns or framework concepts. You know, you could say that update settings and update water tank settings are like service objects. And broadcast details and configuration are kind of serializers. We explicitly decided not to be prescriptive about how people organize their code inside the domain directories, because this allows them to decide what works best for them and to experiment. So sometimes they organize their code by subdomains. Like you might create a water tank subdomain here. Now, other teams decided to organize their code by patterns. For example, they might have a services directory and a serializers directory. Now, some teams initially adopted one style, and then as their team grew and the code grew, they actually changed up their internal organization. And that is great, because now they have the autonomy to do that reorganization with their team without requiring the whole organization to come along with them. Okay, we're just about done. Alan, want to close us out?
Yep. All right, let's review real quick, and then I want to close on a completely orthogonal thought. So we set out on this adventure because we needed to speed up onboarding, make it obvious where code belongs, and to simplify testing. We chose those 4 attributes: clarity, autonomy, accountability, and testability to instill in our code. And we chose to modularize our code and add boundaries as a means of restructuring it in order to support those qualities. Now for the orthogonal thought. Who here has heard of 3x? We have one in the front. 3x is a smashing together of 2 completely separate ideas by Kent Beck. And if you'll indulge me for a second, I'll share these ideas with you. You should definitely go watch the talk of Kent giving this at Pivotal back in 2019. Not right now. You can do that later. The link is in the deck. The first idea is the idea of planned versus iterative development. Planned development is what we traditionally refer to as waterfall, and iterative development is what we generally refer to as agile. The second idea is the idea of concave versus convex curves from economics. I'll need a few more slides to explain this. A concave curve is one that requires very little upfront investment and usually results in a small loss, but occasionally pays off really big. This is venture capital. Next is a convex curve. These are the ones that require a very large upfront investment and usually result in a predictably stable but small profit, but can occasionally result in very, very big losses. This is banking, and I don't like traditional banking. Kent uses a quote. He says, "The 5 worst days in the history of banking destroyed the profits of the last 500 years of banking." That's how big these losses are. So, can you guess which methodology is best suited to which one of these curves? Guesses?
Move on the left, planning on the right.
Yeah, so concave curves favor rapid exploration of many small ideas. That's a perfect environment for an iterative agile development process. Convex curves favor the reduction of risk because the downside's so big. So they're perfect for planned development. This was like an aha moment for Kent, who was like all agile all the time. You can guess which technologies might be best suited to each as well. Where do you think Rails sits? Yeah. Ruby on Rails is the obvious choice for the concave curve. The velocity with which you can ship ideas is phenomenal, allowing you to try lots of things and iterate. And Java is really the more traditional choice for the plan-driven kind of risk-averse projects on the convex curve. Or today it might be Scala or .NET if you're a Microsoft shop. All right, everyone got concave and convex? Cool. Turns out these are actually one curve. They're not 2 curves. And Kent sees these as 3 different phases of development along this curve. The first phase is called exploration. Here's where you are in the concave portion of the curve, and you're running lots of cheap little experiments trying to find that one thing that's going to pay off big. Next is expansion. Here you found something that's starting to grow, and you want to encourage it. So you're trying to like hold on to the rocket as it rides up in the air. Everything in this phase is about keeping up with scaling demand. This is the point at which Twitter bailed on Rails. And then finally, once you begin to get a grip on that scale, you enter the extraction phase of development. And now you're fully into the convex portion of the curve. Risk aversion kicks in. The goal is now to extract value from the existing system and continue to get a smaller profit, but a profit for years to come. All right. Kent's not the only one who's come up with this idea. There's a man named Simon Wardley. He has a post called Pioneers, Settlers, and Town Planners, which describes a very similar curve. This is his chart. He believes there's different skills even that are required for those different phases. Pioneers are the ones who are generating things and coming up with the custom solutions. Settlers are the ones who turn those solutions into products. And then town planners are the ones who turn products into commodities. All right, so if Rails architecture and conventions are well suited for high velocity iterative development, and honestly at a small enough scale, you can ride Rails right through all 3 phases. But for larger code bases, like we said earlier, the Rails architecture kind of falls short. On the other hand, code bases on the convex side of the curve are often built with Java. These languages, or Scala or .NET, these languages don't offer the same velocity as Rails, but they do offer architectural guidance for large-scale code bases. Concepts like design patterns, domain-driven design, and test-driven development all came from this community. Patterns of enterprise application architecture in particular, that's the second book in there, stands out because, ironically, it documents active record. It came from an enterprise viewpoint. So Rails is not incompatible with these patterns. It's just that the Rails community has its identity wrapped up in the world of startups and the one-person framework. But it's totally possible to embrace enterprise architectural.
Hey, I'm going to be talking about how we do structured AI workflows at Shopify. Hey, everyone. It's good to be here. Thanks, Irina, for the invitation. This was a little bit short notice, so if it's a little rough going, that's why. But Yeah, it's the first time presenting this talk because Roast is very new. We just open sourced it a couple weeks ago. And I'm very happy to be here to share it with you. You're actually getting a preview, let's call it a superset of what I'm going to be presenting at the Anthropic Developer Conference tomorrow, which is going to be very, very exciting for many, many reasons that far exceed my talk, so intent. Anyway, yeah, I'm Obie, and I can't take it for granted that everyone knows who I am anymore, unfortunately. I'm that old in the ecosystem. I started back in 2004. Thank you. So I started doing Ruby back in 2004, Rails in early 2005, arguably one of the first people doing Rails commercially at John Deere in like March or April of 2005. And then I wrote this book called The Rails Way, which in addition to generating enough royalties to buy me a proper sports car, let me start a consulting company called HashRocket, which got kind of famous in its day. It's still around, but I sold it years ago. And I have written other books since. And in fact, if you scan that QR code, you can get my latest book called Patterns of Application Development Using AI at a huge 60% discount just for you guys and gals here at SF Ruby. So I'll just give you a second to scan that if you want it. This book is not going to get me a sports car yet, but believe it or not, if you've ever said, hey, I think I have a book in me, you can make 4 or 5 figures with books still. You just got to write about the hottest topics. Rails was hot back in 2007 when I wrote The Rails Way. And note that we've actually, me and the team have kept the Rails Way up to date. You might not know that, but there's a Rails 8 way. And actually, we've been starting to expand the franchise and create other books about different things. But anyway, without further ado, I want to talk to you about the challenges of scale at Shopify engineering. So Shopify arguably, I have to say arguably now because we're at Cisco Meraki and based on what they just said, arguably is the largest monolith, Rails monolith that exists, millions upon millions of lines of code, well over 500,000 tests that I know of in our main app. The main app is only one of about 5,000 Git repos, I think, at last count. And we generate over 500,000 PRs a year, rough estimate. There's a lot of things going on at Shopify. Engineering and tinkering is part of our culture that flows down from Toby, our illustrious CEO. And one of the core challenges that I was given when I started there as a principal engineer in our augmented engineering group was to apply the latest technology with AI to improving developer experience across all of the engineering practices. So how can we take the latest and greatest, the state-of-the-art models, the thinking, the patterns that are coming up, like the ones I documented in my book, how can we make sure that we're using that effectively? And one of the things that I noticed is that across all these teams and all these people that are working using AI, which is pretty much everyone in the company, thanks to Toby's memo, which leaked, I don't know, a month ago now, maybe 6 weeks ago now. Raise your hand if you read Toby Lutke's memo yet. I figured most of the room would have. He basically said it's a disciplinary issue. He didn't say disciplinary issue, but he says it's considered part of your job and will be used to measure your performance, how effectively you use AI, right? In looking at how we were using AI, I saw that there's like literally hundreds of different reinventing of the wheel across the company. I mean, there's not hundreds, there's literally probably thousands of people using and trying to automate their job in different ways with AI. This is everything from Ruby engineers, like most of you guys in the room, to machine learning experts, to salespeople, to support people. It's literally across the entire organization. Using MCP, we're actually pioneering things on MCP. There's a lot, trying to emphasize here, there's a lot of heat. There's a lot of activity going on. But because of that pervasive culture of tinkering, it just means that there's a lot of repetition, and I feel like a lot of lost effectiveness. So anyway, threw myself into creating this what ultimately became the open source version of Roast. We started we prototyped this, and you can actually see. Unfortunately, it's a little small, but we started with applying a structured workflow to analyzing tests. So, you know, some of these tests go back almost 20 years in the main monolith. You know, figuring out the quality of them is something that would be nice if we could get the AI to do. It would be even nicer if we could get it to improve those tests. So I said, okay, that's a good, solid use case. Let's write a framework or something to like actually do this in a proper way, knowing that even if we failed at being able to improve the test, I at least would have some like you know, side benefit of having some tooling I could give to the rest of the company. So yeah, there's this new thing called Roast. Anyway, I picked up some reaction. This is the latest kind of raves that I've got that I found on the Slack, and I thought that it described really well what Roast does. The ability to interleave deterministic processing steps with an LLM doing a specifically defined task on a data set that we've already curated. So most of these workflows, when I say structured AI workflow, what I mean is a series of steps, that's the workflow part, but at least one or more, or perhaps all of those steps are given to an AI with a specific task. So a narrowly defined prompt. If you've done enough prompt engineering, you know that the narrower you can make your prompts, the more specific, the better. Right? Like it's okay if the prompt has a bunch of context, but in terms of what you're asking the AI to do, it's better if you just ask it to do one thing at the end. So if you have a big job for the AI to do, and you can decompose it into a series of steps where at each step you're asking the AI to do one thing. Identify a particular file that I need to read, you know, for the next step. That's the end of the first step. And the next step, take this file, find its dependencies, and give me a list of its dependencies, for instance. That's the end of the second step. That's what I'm talking about. Often, for people that are, you know, in this space, they say, well, why can't you just give a list to an agent? And it is true that you can give lists of things to do tasks, even quote unquote workflows, to an agentic tool like, for instance, Claude Code. And in fact, nowadays, Claude Code will make a list itself if you give it a complex task. If you tell Claude, hey, write me a feature, blah, 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 the first thing it'll do often is to say, okay, I need to create a list, and it'll create a list, and it'll try to follow it. And unfortunately, I don't have my speaker notes, but let me turn those on here. Yeah. So specifically, when we're talking about agentic tools, like I just mentioned, Claude Code, it does kind of work, but it's not ideal. They're not ideal for workflows, and the reason is that what they're best at is exploratory or ambiguous tasks. So when I say best, I mean like, you know, what's the most productive use for them? You could totally try to force it to you know, and I've seen this. I actually saw an example today. I was pairing with someone in our ML group, and they were feeding a 13-step workflow into Claude Code. And at every step, they were kind of pleading, please do this thing. And if you can't do this thing, then stop. You know, it was kind of like, it's kind of like giving instructions to a very, very unreliable, you know, worker, and where you're having to emphasize those things. Okay, let's decompose this. But what are agentic tools good for versus a structured workflow like tool like Roast? The exploratory, ambiguous, multiple unpredictable steps. So you don't know what's going to come next. You can't have defined that workflow because you don't actually know. It's more like a research task, right? What else? What if you have to rely on the LLM's reasoning and judgment more than your own? Maybe you're in a domain that you don't understand, or maybe you're actually using the power of the large model to be able to make decisions that you couldn't have known beforehand. or simply that your path towards the solution was not known in advance. So that makes, take all those things together. That means that agentic tools are basically good for feature development and coding. You can say, hey, I want to work on this feature, or grab this issue from GitHub and work on it. Or for research and discovery. It can be even scientific research. I've seen people starting to talk about using Claude Code and tools like that for kind of basic research. They're great for that. Now, in contrast, structured workflow orchestration, and Shopify's Roast is only one of the tools you can get for that. But structured workflow orchestration shines when tasks have predictable, well-defined steps. You see consistency, repeatability, and clear oversight. You want to leverage the AI for intelligent completion, all the things I just talked about, except in a narrow scope, in a scope that fits inside of a series of steps. Right? These things are not mutually exclusive. I'll actually show you how they work hand in hand. But that structured workflow includes processes that you can decompose into deterministic stages. And this is the first time I'm saying deterministic, and that's very, very important. What I neglected to mention in the previous slide is that no matter how well you do your prompt engineering, when it comes to giving an agent a workflow, it is still non-deterministic, which means it can totally go off the rails, no pun intended, as it's going through there and decide to do something else. It could try to cheat, try to skip steps. You actually never know. I can tell you from experience. As I mentioned before, these work hand in hand. And in the case of, for instance, of Claude Code, which is the coding agent that's built into the current version of Roast, we can actually get code to use Roast as a tool. So we can say to Claude, like, hey, we're going to work on improving tests today, and the way that you're going to know what's wrong with this test and what recommendations to do is you're going to call Roast test grade and then pass it a workflow for test grading. And Claude Code will happily invoke Roast. Roast will go through a series of steps, do a grade, and consistently, because it's based on a rubric, produce a grade and then produce recommendations, and then Claude Code is off to the races implementing the recommendations that were produced by that workflow. Inversely, Roast can invoke Claude Code, and Claude Code is actually the implementation of its coding agent. So for instance, when we've been experimenting with mass test generation. Talk to me later if you want to know the do's and don'ts about mass test generation. But anyway, we have workflows that involve getting a list of subjects in a code base. So like, let's say you point it at your models directory and you say, hey, I want to generate tests for all the models in this directory, okay? So it's going to take one model at a time, and it's going to look at that model file. It's going to read dependencies. That's the first step. And then it's going to look at other things, and it's going to look at other things, and it's going to make a plan, and then it's going to pass that plan in command line mode to Claude Code and say, hey, work on this. That one step where it passes it to Claude Code and says, work on this, it can actually have more steps afterwards to evaluate what Claude did. So that's that inverse relationship. And I just have this is a little bit boring, and I'm probably going to skip it, but essentially showing you for test generation, as it's going, it will actually get to the coding agent start. And when I was recording this, it basically copied the result of the test generation just to run it to show that it did actually generate a working test. But yeah, it's a terminal app, it's spitting out output. It's saving session, it's caching function calls. It has a lot of kind of the basic workflow orchestration stuff covered. So you go, Obie, this is amazing. How do I get started? Okay, well, first of all, caveat, this is like a 0.1. We're really, really early. This has been extracted from working code. It's being used in probably a couple dozen different use cases now as a gem. that I know of in the company, and is about to take off next week because we have our summit and hack days, and I've seen that a lot of teams are going to be using it. So expect there to be challenges as soon as so PRs are very welcome. I think this is actually going to be really big. So if you want to, get involved, get PRs in there, get involved with the fledgling community, we probably have, I think, at least half a dozen contributors just in the last couple of weeks. So that's really exciting. But basically, you can clone the project. You can think about it this way. We provide some example workflows to get you started. I think the documentation is actually not too bad, but we do provide you with those example workflows because there's a bit of a learning curve. The workflows are defined in YAML. And yeah, you install Roast, and it's basically a command line app. You point it at a workflow. You run it in the project directory where you have the targets that you want to run your workflow on. Because of its origins, I guess, you can run it in two modes. It's kind of like a target list mode where the first step of the workflow is kind of deciding, setting the scene, if you will, for what the workflow is going to do. Or you can pass it a list of targets, which is like the case that I mentioned earlier, which is you point it at your model directory or you point it at a list of tests or something like that. And in that case, it's going to run the workflow for each one of the tests or each one of the targets that you pass to it. So I don't know how visible this is. I'm sorry, but this is like an example of what the workflow YML looks like, the configuration. And is it visible? Otherwise, I won't bother. So.
There's screens.
Yeah, so, there's a name. You can declare a list of tools. You can provide options for those tools. You have steps. You actually have the ability to run steps in parallel, which is very important for performance if there's things that can happen at the same time. Obviously, a lot of these AI check completions are very slow. And you can set non-default attributes for the steps. And what I mean by that is that, basically, the whole roast workflow kind of defaults to, right now, it's Claude 3.7. But you can change the default, or you can change it per step, which is really nice because the models have different capabilities. So for something that is relatively simple, you might be, able to use one of OpenAI's mini models. The other thing that's really nice that we built as a result of having to use this internally is that it saves the session every time you run the workflow, which means that you don't have to run the whole workflow as you're developing it. So if you have a long workflow, and you get 1, 2, 3, 4 steps through it, those 4 steps are working perfectly, the next time you run it, you can just say start at the 4th step and continue iterating down. So basically you can hit that one step at a time. Extremely important because those steps are often so slow, right? Yeah. There's a bunch of other little details and things I won't get into. You can ask me questions about it later if you're really interested. But yeah, that's Roast. And if we have time, I'll take a few questions. Any questions? In the back.
Are you familiar with cursor rules, how they work? And if so, how does this compare with how Cursor uses the rule sets?
Yeah, cursor rules. The question was about cursor rules and how they're used. Cursor rules and Claude MD and I think Agents MD. There's a whole bunch of different things that are essentially instructions for the agent. Those provide those agentic tools that I was mentioning earlier with instructions about how to do its job. That's kind of orthogonal, if you will, or not exactly related to Roast in the sense that Roast is providing a framework for how to go about doing steps in a long process. And some of those steps might include using a coding agent. And when you use that coding agent, the coding agent can use cursor rules or Claude MD. Got it. I got a thumbs up. So, yes, sir.
For the step caching stuff, so you don't repeat unnecessary work. Is it built-in support for just hashing contents of the different files and stuff to make sure and see if there's changes that it needs to re-examine or something, or is that all just kind of you kind of hand code on your own sort of situation?
So it caches. You can turn on caching for tool function calls, in which case it does, cache using a key that's based on the parameters that are passed to tool functions. So as you're developing, if you're kind of using the same sample set of data and getting similar function calls, those can get accelerated. If you're just doing replaying, this is mostly for use in, when you're first developing your workflow, which means you're using kind of like you're hitting the same batch of files over and over again, just to try to, get all the way through the process. We very quickly figured out sitting there and watching it do the first 3 steps, for the 500th time, because you're working on the 4th step, is not efficient, right? Not a good use of time. Question in the back.
Have you thought about using another task-based management like Ansible or stuff like this?
The question was, have I thought about using Ansible for what? Sorry?
I mean, doing kind of the same. Yeah.
Task management.
Is that so I know Ansible is like kind of a build tool or infrastructure management, yeah. The answer, frankly, is no. I mean, I've also heard this kind of looks similar to GitHub Actions or workflow kind of thing. There would be drawbacks to using an existing tool because of the things I just mentioned, right? This is very specifically meant for interleaving, kind of regular steps with AI steps. And what's not being shown here, and unfortunately I just didn't put it in the talk, the workflow, the step definitions can be very, very light, and they don't even have to be AI. So for instance, you can put bash commands right into your workflow steps, capture the output, feed them into the next step. Also, if you have a lightweight prompt, which doesn't require a file, you can literally express the prompt in 1 or 2 sentences, and you want to put it directly into your workflow configuration, you can. You literally just put it in line. Keep the classic example is you do a whole, you do a dozen steps, and at the bottom you say summarize, because the last step is what you care about. I'm glad you asked that question. It gives me an opportunity to kind of talk about what makes this different than just a regular workflow tool. The workflow that is defined in that file that I showed you represents a conversation with the AI. So it's got a backing transcript, right? The prompt that's associated with the workflow itself is the system directive of that conversation. It's the system message at the top of the transcript. Every step is 1 or more exchanges in that transcript. I'll pause for a second. I see some of you nodding, so I think that makes sense. But essentially, as you go from the top to the bottom of that workflow, you are creating a long-running conversation. The downside of this is if you have a very long workflow, you're going to run out of context space. So if you look at the issues board associated with roast, you're going to see that on our roadmap, we have things like auto-compaction. And I'm not sure if I added it yet, but one that came up this week was isolation. So being able to take one of these steps and say, isolate this from the main conversation, right? And then by convention, what I'm thinking of is that when you do an isolation, you can say for this step, okay, isolate this into its own kind of side conversation, but then summarize it and put it back into the main workflow conversation. Thank you. First, yeah.
Do you fine-tune the models? Do you train the models on Shopify code styles or code?
There's undoubtedly some fine-tuning going on somewhere in Shopify. I've seen mentions of it, but I'm not specifically doing any fine-tuning.
Okay. Can you give an example of something that you're using Roast for in the developer tooling for your team? Something that you couldn't have even dreamed of doing without Roast and LLMs?
Sure. The question was, just repeating the question. Are we recording this, by the way? Oh, we are. Okay, good. Sorry, what was the question? Okay, an example. An example of what we're doing with Roast that we couldn't imagine doing otherwise. I don't know that we couldn't imagine doing it otherwise, but basically there's we've been asked to experiment with mass test generation. And mass test generation is very, very complicated, especially on a code base as large as Shopify Core. So, you know, just telling your coding agent, imagine telling Claude Code or Cursor Agent, I'd like you to generate 100 tests or something like that and just let it go. It gets off into the weeds very, very quickly. I heard a term that I loved that I think I'm going to start using and blogging about, and you might want to do as well. Anti-entropy. We are the anti-entropy, humans. And this might go on for a while. In fact, hopefully it does go on for a while. We're fucked. Nervous laughter in the audience. We are the anti-entropy. We are the thing that keeps these processes from spiraling out of control. Now, in the absence of a human, for some of these applications, a structured workflow tool or orchestration can function as the anti-entropy agent because it keeps it on between the guardrails, right? So you only let off your agent, you only give it a little bit of leash. The more leash you give it, the more that the small errors and judgment and hallucinations and misunderstandings take effect and they compound. And they don't compound linearly, if you know what I mean. So the shorter leash that you can give the AI, the better. So it's not so much that we can't imagine doing these things with agents, it's just that it's not feasible. It just does not work. In fact, some of these more ambitious things that we're doing just don't work, period. They don't even work with an orchestrated workflow because they're just too hard right now. However, as the new state-of-the-art models advance, they do become more feasible.
Can you say something more specific? Like, we're using it to remove, to change this?
So for instance, the model, yeah, so getting more specific. For instance, the models don't, the state-of-the-art models don't have a great grasp on sorbet, which is the typing system that we use. So telling it to use the sorbet tooling and to understand the results is not very fruitful. So if you interleave steps of interpreting and writing sorbet with actual calls to the tooling which are predefined, it works much better. You don't have to rely on the agent understanding how to use sorbet, how to invoke those results, how to interpret those results. Another thing, another concrete example, anything that involves grepping your source code, interpreting large data files, interpreting large JSON responses, right? The ability to make an API call, get a ginormous JSON response back, pipe it through JQ, you know, just to extract what you want, and then give it to the LLM in the next step is very, very powerful. Again, it's not that I can't imagine doing this with an agent. You absolutely can imagine, you can try it nowadays, it just doesn't work well because it bloats that context and it ends up distracting the agent from what it was supposed to do. There was another question, yeah.
Yeah, how do you measure prompt effectiveness? Because you have like many steps, and since maybe you run it at scale at Shopify with many developers using it, how do you measure that like a given prompt is being effective on the task that you're giving it to for the AI agent to execute?
So the question was how do we measure prompt effectiveness at scale, perhaps, or not? But how do you measure prompt effectiveness? I think there's a few different ways to interpret that question, but I feel that when you get into doing these kinds of processes, you're kind of post-prompt engineering. There's still some prompt engineering, but I don't ever think about prompt effectiveness in a big way, like in a big picture way. Because the prompt effectiveness and the prompt engineering that I'm doing, since it's narrowly focused, is an implementation detail of a particular workflow step. I don't know if that answers your question, but I'll contrast it with something else. Like when you're working when you're working in a more agentic fashion, or when you're working in chat-oriented applications, the prompt, that you might share with others and its effectiveness is more important. Some of you, I'm sure, have like a library of prompts that you use for different purposes, right? And then you care about the effectiveness of that prompt and tweaking it and whatnot. But when you decompose this work into small, into very, very small bits, then there's not as much prompt engineering going on because you're giving very, very specific instructions, and you're reducing the amount of the instructions, down to a manageable level. Again, the context might be very large, like what it needs to do that last prompt, the thing that it's returning, right? The question that you're asking might be very, the context might be very large, but what you're asking to do is very small. And at that point, it's just easy. I feel like it's easier to optimize. Yeah, thanks. Thumbs up. Cool.
I had a similar question about how you evaluate model effectiveness, because you can set one for each step, but how do you make sure the one you choose is the best one? And then how do you make sure that that remains the case as new models are released?
Yeah, the question is, how do we evaluate model effectiveness for each step? And frankly, that's an art, not a science right now, as far as I'm concerned. I mean, we do have well over 1,000 ML specialists, and I know that they do, methodical evaluating of different things. But I don't have a lot of hands-on experience doing that myself, so I can't actually give you like a really, really good answer. What I can tell you from experience that I've done, and this is colored by the fact that I've been doing this for 2.5 years now, meaning prompt engineering, is just like I kind of have an intuitive sense of like, hey, this will probably work with one of the smaller models, or not, or I'm going to really need a bigger model for this. Yeah.
Can I just use this chance? Just wanted to use this chance. We're discussing having another speaker at the next meetup that would just focus on evaluation. Come next time.
So there's a plug for next month's meetup, because we're going to have someone talking about prompt evaluation. That's cool. In the green shirt?
Yeah, so I have a pretty similar question, I think. So in my experience, if you have a workflow that is done by AI and it has a lot of steps, you kind of have like, maybe the first step is done 80% correct, then the next step is done 90% correct, and it just cascades, right? So it just the end result is like pretty bad as a result, right? So my thinking, my question is, do you have a way to control that, or is it more of what you said about like the art, right, of prompt engineering, and do you have the science for it maybe? Because if you ask it to generate like 100 tests using that workflow, it could generate you hundreds of dollars of cost, right? Especially using those most advanced models.
Yeah, I'm going to rewrite your question for brevity as like, how do you prevent compounding errors, or how do you mitigate compounding errors in a long series of steps of a workflow, right? Is that fair? You basically want to use what techniques I think have been referred to as LLM as judge is one of the ways. I mean, there's ways you could formalize that and have evals and things like that, but that's kind of like the pre-step. But if you want to do it at runtime, you have to use LLM as judge kind of techniques. There's probably other techniques, but basically you interleave steps that evaluate the previous step. And depending on what it is that you're trying to do, that interleaving, can be anything. It could use traditional ML. It could use comparing to a reference.
Is it possible to have like a stop condition? Like you have a judge, and if the quality is too low by the LLM judge, you just stop?
So the follow-on question is it possible to stop if the quality is too low? So actually, the next series of features that we're going to add to Roast, and again, you can go look at the issues if you're interested. I've recently just added the ability to loop, and you can kind of like loop until, or you can do each kind of looping as at a step level. So Roast itself is intended to loop over a series of target inputs that you give it, but at a step level, you could do like loop until a certain condition, and the condition can be whatever condition you want to be. It can be, and then if you look at in the roadmap, essentially as expressed in the issues, you'll see that we have everything that you're asking for, like basically the ability to stop, the ability to jump, the ability to branch, down different conditions. So everything you would kind of expect in a full-featured workflow tool. In the red shirt. Oh, actually, you asked one already. In the blue shirt in the back.
Yeah. Have you thought about making it just like a more like an MCP client instead of like being too deterministic? It sounds like you can like at some point add more tools that way, or is that like not something?
So the question is, let me rewrite your question again. So the question is, how does MCP fit into this picture? Is that fair? Yeah. So Roast is built on another library of mine that I really like called Ray, R-A-I-X. Okay. So I see some of you nodding your head, so you're at least familiar with it. And I recently added experimental support to Ray for MCP. Ray is kind of like that bottom abstraction layer that ties you to chat completions. And I do think that it would be very nice to be able to just like declare an MCP configuration or point at one in your Roast workflow, but that's not supported yet. If the question was about using Roast as an MCP server, then the answer is no. Not right now. As a client, yes, absolutely. Right now, Roast looks for its .roast directory, and it looks for initializers there, which is where you would add your own tools, and the tools kind of follow a well-defined pattern for adding functions. So if you wanted MCP, you would wrap them there as a client. All right, one more question? One more question, yeah, okay.
Okay, so I'm curious about what is the workflow for the developer? So you're developing a feature, for example, you road test, and then you ask Roast to roast what you did?
Okay, so the question is, what is the what was the word you used? What is the
developer workflow?
The developer workflow for using Roast. So Roast can be used to implement literally any workflow, and actually you don't even have to write it in Ruby. Roast happens to be implemented in Ruby, but like today I was working with one of our ML engineers who only knows Python and DBT, right? So like they didn't know any Ruby. And it's okay, like, because it's basically a series of prompts and command line expressions. The name Roast is not actually an acronym. It came from the very first application or use case that we did for this, which was to roast or criticize existing tests, right? So that's why it was called Roast. And there may or may not be an Easter egg in there that can get it to roast your. There was in the first version. It's not in the gem version anymore. But yeah, no, that's the reason it's called Roast. But what is the workflow? It's like asking what's the workflow for Rails. I mean, you can literally do anything you want with it. It comes out, the gem has some examples for things like test grading in it. But those are only really meant as reference for you to, inspire your imagination. For it. I wouldn't say that there's like a standard thing that you do with it. It's a framework. Cool. Thank you very much.
I thought maybe it was called Roast because every time it runs, it lights a GPU on fire.
Lights the bank account on fire.
Yeah, there you go. All right, our next talk before our break is Todd Kummer talking about deploying a hobby project on Rails 8 and Kamal.
All right, thank you everybody. I'll try and keep it moving so we can get ourselves to the break. Tonight I'm chatting about deploying a hobby project with Rails 8 and Kamal. That's sort of kind of the dream of Rails 8. So I tried to live the dream, and I want to tell you a little bit about it. The sales pitch very briefly. Rockridge Solutions is a two-person consulting firm. We specialize in Ruby on Rails. We've been working together 20 years. My advice to you if you want to start a company is do it with somebody you like. It makes it much easier. I'm going to keep moving a little bit. In case you're not familiar with Kamal, I had AI generate this slide for us so that we would all become familiar with it. I think the origin story of it was back when the cloud became expensive, and they said, we're going to pull everything from the cloud. So they needed sort of all of that in-house. And so that was the birth of Kamal, using tools that we're kind of all familiar with, Docker, SSH, Git. And then last down there, developer-friendly, right, solo or small teams. And then simplicity, right, is what I was looking for. So I will, again, try and be quick. This is just an intro to Kamal, not a tutorial. My hope is that you walk away from this saying, hey, I think I could do that. Not that you could become a Kamal expert, because I don't think I am. And that's kind of the beauty of it, is I don't think you need to be. So I'll talk a little bit about the decisions, some of the challenges along the way that you face when you're trying to do this. Really just talking about my journey through this. The project really doesn't matter, right? Because that's not what we're talking about. We're talking about deploying, but I wanted to give some context for it. So what is it that I wanted to do? What is my hobby project? And by hobby, I sort of mean non-commercial. Oh, there's one up there. I can see the screen. Sorry. That caught me by surprise. Pleasant. So I wanted to replace QuickBooks. Again, a small partnership. We're paying $1,000 a year for QuickBooks, and that seemed like a lot of money. We sort of do department accounting. That's why some of the other solutions didn't work for us. There was some complexity there. My partner doesn't love accounting, kind of gives him the hives. So I was the QuickBook guy. So I thought, well, what if I build a system that's a little more user-friendly? And then one of the features of it is we don't need the month-end processing, right? At all times, you can kind of get a real-time snapshot of where you're at. So that's the context. Again, not necessarily that important, but thought I'd share it. The first questions you might ask about doing this is, well, how long did it take and how much did it cost? So I kind of went back and looked. My first commit was October 25th, and this is, just last year. It was deployed first January 22nd, and right in between was the holidays, and I'm not sure how much work I got done during the holidays. And then the last item I have there noted as on my milestone is the completion of the QuickBook conversion. And what that ended up being is I took 15 years of QuickBook data and I converted it into the new system. And in order to do that, I had to build a bunch of features, right? So it sort of ended up kind of being a feature list in order to support all of those things. So that's that last one. I wasn't working full-time on this. But I didn't have a full-time job, so it did get a fair amount of time. It wasn't just nights and weekends is kind of what I'm saying there. The cost was great, right? So hobby being, I don't want to spend a lot of money on this. I bought a domain for $12. I highly recommend it. It's just fun, right? Now your app can sit on your own domain. And then I'm paying $6 a month for the hosting, and that's it. And so that comes in well under $1,000 a year. However you do that math. So the unknowns, the things that sort of scared me as I started out. And of course, this is from my perspective, right? I'm a programmer. I've done some DevOps. I'm not a DevOps professional. So if you do DevOps a lot, these things, the things that scared me may not scare you. So keep that in mind that this is from my perspective. Right, so first, okay, if I want to put something on the internet, I got to have a machine out there that's available. So I had to figure that out. Next was thinking about the database. Do I want to use a managed database, which would be an additional cost, or do I want to try and do something manually? The way Kamal works is it pushes to a image repository, a container repository, and then pulls it back down. So you do have to have container registry out there. Secrets, right? This is always a problem. This is always hard to do, right? Whether you're a one-person shop or a 1,000-person shop, secrets are kind of a pain. And then the last one, security, provisioning the server, right? I'm not a Unix person. I kind of giggle every time I get to a Unix command line because it's fun and it's neat. But it's a little scary to think that I'm in charge of the security for it. So those were sort of the things that as I sat out to do this that had me worried. And so I'm going to talk a bit about some of these. And the other one briefly, I had a joke about, could you see this from the back? But this setup's so good that probably everybody can see this. The point of this slide was simply that there's a lot of decisions you make just to start a new Rails project. And I have sat down with much enthusiasm, typed Rails new, and then never gotten any further, right? Because there's just so many decisions. So no advice here, but just don't be intimidated by it. Sometimes you just have to push through that silly first step. So what did I do for the database? So a couple options that you have. Right, if you use a managed database, which is great, then you're really just filling out your credentials in your database YAML, and it's that simple, right? So for that cost, you get everything, well, not for free, it's for that cost. Another choice is there's a feature in Kamal called accessories. And so this could be a database, this could be a cache store, this could be Redis. And so it spins up a Docker container, right? Similar to the same as it would spin up your app, right? So these are going to be put out, but they're not managed in the same way that your app is by Kamal. So that's an option. You could run that in a container and a database. It's an easier one, but then again, you're sort of on your own with what you want to do with that. I went really with the easiest one, kind of the dead simple one, which is I mounted a volume. It sits on the server. And it's SQLite. And so the cost was nothing, but I am responsible for it. So what does that mean? This would not be something that's ready for prime time, right? I understand my database. I understand the number of transactions that go into it. Anytime I do a lot of work in the system, I just run a backup. So my backup was kind of a fun script to write. One of the challenges, I'm trying to think if I'm talking ahead of my slides. One of the challenges was database credentials, right? Again, secrets are hard. It's one of the silliest things about what we do, but one of the hardest things. So what I did is I wrote a script. It's going to SSH into the server, and on the server, it's going to use a Docker exec to run a rake task, right? So that rake task has access to the database, and it's just a custom, it's DB backup, right? It writes out a file, and then I simply copy it down. And so I didn't have to, that process doesn't need to know the database credentials. And so that worked out pretty well. One of my to-dos is to automate this so that I have regular backups. But again, one-person shop, living the dream. So what can you do for the secrets? It has a secrets file. It's a little bit like the credentials, but it's not encrypted. There's a comment that says, hey, you can put secrets directly into this, but then don't check it in, right? So then you're just managing it locally. It can read from a .env file, so that's another option. What I went with was it has a secrets helper that makes it easy to get secrets credentials out of a password manager. And so there are a number of options there, including the big players there. I have like a 1Password family account, and so I just set it up using that. And so the secrets file, it's almost like it is a bash script. It goes and it uses a connection to 1Password, and it reads those out, and then it injects those kind of up into the server and into your containers. And so that ended up being a pretty good solution. If you want to extend that a little bit, you'd need a password manager that can be shared, right? My family plan isn't going to work. So if I ever want my business partner to work on this, right, I just need to upgrade either the business or the team plan, sort of your standard secrets problems. So this slide is simply 2 links, right? Which just kind of goes to show, number one, I don't know a lot about security and provisioning. But number two, it just wasn't that hard. So I recommend the Kamal handbook. It's nice, especially here. And this is why I bought it. But it has a nice overview on all the features. And so if you're looking for that tutorial, I recommend that. And then the second link there is just a blog post. He essentially took all the advice from the book and wrapped it in just kind of a cool Ruby script to run it. So those were the two things I did. And with those, I feel pretty good about it. I feel like someone smart has told me how to do this, and I'm doing it. And of course, right, I'm running a server on the internet, so you got to go out and update the libraries and do all of those things on a regular basis. Authentication. So new to Rails 8, there's a generator that handles this. And so that's the choice I made. And this was, again, one of those things that, I mean, everyone's worked with device, I think, once in their life. And this can be a little bit intimidating. I ran the generator. It works pretty well. I feel pretty good about that. It does require Action Mailer setup to do the password reset. So there, again, was a kind of another hurdle. Is, okay, well, how do I do mail? And so I went out and I found a vendor that had a cheap plan. I think 1,000 emails a month for free, and there's no way I'm sending 1,000 emails, so it seems like a free tier. One issue I found is that DigitalOcean, which is the hosting provider I used, blocks the SMTP port that is needed to communicate. So the vendor, which is AhaSend, is the vendor I picked. Also has a REST service that can send emails. So then I just had to write a delivery method that took, you could hook into Action Mailer, then hit the endpoint. And I think I did get us to break pretty quickly. Finishing up here with the takeaways, right? What did I get out of this? The first, to me, was a big one, proof of concept, right? In theory, I'm a programmer, and I have everything I need to put an application on the web. Now I have it in practice. I did this, and so it worked out. I've got an awesome new accounting system. There is nothing better than looking at something and saying, you know what, wouldn't it be great if? Right? I showed it to my partner. I had him enter expenses, and he wanted to split the expenses, half of it here and half of it there. And he says, well, what if I could just do /2? I said, oh, yeah. So now it does that, right? It's my software. I can make it do anything I want. 2 gems. As I was building this, I pulled 2 gems out of it. I found some functionality that I plan to reuse. In fact, I'm already reusing. And so I was able to extract those. Again, the confidence to do it again. I am currently building, would you believe, an AI system that helps with some marketing materials. And I'm not sure I would have pitched it, right? Because I am the one-man shop, right? And I'm not sure I would have pitched it without having done this and felt like, hey, this is doable. This actually is what they say it is. A one-person shop can get it done. And then the last note there is one of the things I think that's true about AI is we may be coming to a place where bespoke software will become more popular than SaaS. Why would you settle for the limitations of a SaaS product when you can do everything yourself? The tools are really, I mean, we've seen some things tonight. My experience building this, I definitely leaned into AI. I think it's going to be easier and easier to build solutions. Of course, I'm not saying SaaS is going away. There's lots of great uses for it. But I think bespoke software is going to grow and get better. And certainly, right, I'm using bespoke software and pretty happy about it. So thank you. Apologize if I went a little bit fast, but I think that was what was called for.
Hello, everybody. My name is Kamal, and together with Dave, who's also here, and SF Ruby, we're organizing a hackathon. So, surprise, surprise to nobody would expect it. This is an AI hackathon, so nobody's doing this. I don't know. I intend to learn that from the participants. So the idea is that Rails has always been this one-person framework, and this hackathon intends to test what is the limit of that with AI, right? Because now we have vibe coding. You can just do so much more stuff as a small team, as a lone engineer. Like one thing that I'm curious about is, will it be possible for somebody to actually launch an app during that hackathon without even touching a keyboard, right? Because technically you could just dictate the instructions to a text-to-speech or speech-to-text software and then have the agent do it for you, right? So let's find out, is it possible? And also here's a tweet I found recently that I think is very, very true. These tools are very new still, right? And I think at some companies you can't even use them yet. So there's so much opportunity in just watching other people and how they use them, right? We talked about new tools today, right? Some like I didn't know this one from Shopify, but maybe you could use it to like develop some tests or whatever for during this hackathon as well. So that could be interesting. Here are some details. We already have a date. It's going to be Saturday, July 19th. So pretty soon. It's going to happen at Sentry HQ. If you've been on some of the previous Ruby events, they already happened there. And teams are either solo or very small, up to 3 people, your choice. We're also going to, if you don't have a team but you want to work in a team and get to know some people, we're going to help you. There's a SF Ruby Slack. We're going to facilitate, a get-together or whatever online, and you'll be able to find somebody who will work with you. And there is no entry fee. You just come and RSVP online. We have some open spots for sponsors or jurors. So if you want to help, you think you're the best vibe coder in the city and you want to teach everybody your methods, you can come. If you want to get in front of all the Ruby devs that will come as a company, you can also hit us up and let's talk about that. And now you can also sign up already, right? There's a QR code that you can use and sign up for the event. We'll keep talking about how it's going to proceed. On that page, it's pretty much the same page that you use to sign up for the standards SF Ruby event. And again, if you want to contact us, there's the email address, and you can also talk to us on the Slack workspace of SF Ruby. That's pretty much it. So, thank you.
Hi, everyone. Oh, yeah. Okay, I got it. I think mirroring would have been easier.
Well, you can go back.
That's all right. I think I can figure it out. Wow, what an honor. So I'm Chris. I'm a co-founder at a company called Primary.Health. And one thing that we've been trying to do, because we're we're bootstrapped and we don't have as much pressure as like a normal VC company, is we try to open source the stuff that we build that we find to be useful. And one thing that we found, so we're in health tech and we import a lot of data, like user-driven data, and it's just a really hard problem. And over the past 4 years, we've rebuilt a CSV importer, I think 4 or 5 times now. Yeah. And basically at the start of the year, we were like, all right, let's try to figure out how to get this done one time forever from now on. Because we have a couple apps. And so this is what we end up with. Full disclosure, it actually has nothing to do with Ruby. It's actually just a front-end library, but we are a Rails shop. And so we took a lot of pains to make sure that React was not, because we use Stimulus for some of our applications. And so it was actually a little bit of work to get React to pull it out of these things. Yeah, I'm sure you guys know why CSV uploading is hard. I'm gonna see if I can pull off this demo. I have some examples here. This is probably the most relevant one. So like, okay. Oh yeah, and then it shows up on my end. Hold on. No, I got it. Okay, yeah. So like this was something that we work with a lot where like you have like an employee upload and then you have companies, but the company data gets duplicated because like the companies are kind of like one-to-many to employees. And so something like this, you know, with this, we can like basically upload this in a way where it shows up in 2 separate sheets. So like the user can upload like one CSV, we split that up automatically. And it supports like persistence. So if the page refreshes, you don't lose your stuff here. Edits could be done, and then this could be imported. So we launched this like 2 weeks ago. It's gotten like pretty good reception. We actually got our first PR submission just randomly.
Nice.
It's actually somebody from Korea, I think. And they're trying to add like, so they're trying to, so this is, they added like a virtual table so that it can support now uploads of like, I guess like hundreds of thousands of rows. So I don't know what they're uploading, but it's a lot more than we do for sure. But yeah, huge shout out to Taehi. Taehi? Yeah, I can't imagine he's watching, but yeah, no, it's great. So it's Hello CSV. And just this morning, we ranked past these guys used to be first, Hello World stock CSV, and we passed them finally. So I think we made it.
Awesome, thank you. I'm going to let it slide that it's written in JavaScript.
We did our best.
Hi, these guys are way more prepared than me. I have no visuals. Hi, my name is Sarah May. I have been around the Ruby community for a while. And I just wanted to say that I have a newsletter now. I used to be on Twitter a lot. I'm not on Twitter anymore, basically as soon as Elon walked in the door. But I am experimenting now with longer form. So if you're interested in my thoughts on like software and the tech industry and like where things are going, it's sarahmay.substack.com, and that is spelled SARAHMEI. Thank you.
Hello, hello. I am back again. So, whenever we had Fito and Alan earlier, they showed that lovely little graphic of Ruby books over the years and kind of how that evolved. You'll notice that Eloquent Ruby's back there in 2011. I really love that book. I miss having an updated version. In fact, I've written an entire series about updating that. Apparently, that got popular enough that we were able to have a discussion with Russ, and Eloquent Ruby version 2 is going to be coming out hopefully in 2026. We're working with Pragmatics programmers to make that happen. We're about 10%-ish roughly done, and we will hopefully have something to hand you all eventually.
Hey guys. So today I'll talk about 2 events that you should not miss in 2025. And this is going to be quick and easy, just a little trip I'm going to take you onto. Can anybody guess where this is? Where? No?
Brighton. Brighton.
That's right. So this is Brighton. This is Brighton in the UK. And this means that I'm announcing Brighton Ruby, which will happen in June 19th, Brighton, UK. Why is this event that you should not miss? It's because it's a legendary all-female lineup. This is a very unique situation. I think we should all support, and Brighton is a great city. I think we should all fly there. So Brighton Ruby, June 19th. Please scan the QR code if you want to attend the conference and learn more. This is their website. I'll give you a second to scan, okay? Next one, you're not gonna guess. Or you might, I don't know. Can anybody guess where this is?
Duluth, Minnesota.
No.
Portugal?
Yes. Yes, we've got a winner. So this beautiful place is actually a city in Portugal. Look at this vibrant colors. It's just gorgeous. So this is Viana do Castelo. And as someone helped me here, this is Eurocore, one of the biggest, actually the biggest European conference. What's so unique about this conference, if you don't know about this, is people actually self-host it. So one of the attendees volunteers to host the event. So this means that the organizers are different every time and the cities are different every time. So this is a very unique experience. It's going to happen in September 18 to 19, Viana do Castelo. It's going to be a wonderful experience. If you haven't been to Portugal, this is your chance to have a good time. And actually, the organizers gave us 10% off. So please scan the code to learn more about the event. And if you don't want to scan the code, you can use the code meetup SF Ruby for 10% off. So see, this was quick. I hope you go to these conferences and have a great time. Bye.
So, this is a fairly long talk, and I apologize in advance for that, but we'll go ahead and get started. So I do have this magical little book right here that I do like bringing along with me, and the magical book is going to do something very interesting here in a second. So, glad you could all join me today. If you could go ahead and grab a seat because we're about to get started. First off, who am I? My name is Brandon, but that's not important because we're on a time crunch, so we're going to go ahead and get into it. Now, each major section of this talk is going to indicate whether it's a story or a code segment, along with the lemurs who will be speaking in each section. If it's code segment, you're going to find a QR code there on the main slide, and all subsequent code slides in that section will link to the same file with examples on that section. I'll also post all these links over in the Ruby Slack channel afterwards. So, shall we go ahead and get started? Deep in the library. We find ourselves in the grand libraries of the Master Violet, an infinite well of information and wisdom in the world lemurs. Well, why the library, you see? Well, there's a particularly naughty lemur named Indigo who's been repeatedly banned from the library, along with his friend the Escher cat. It's been about 6 years since they last had a chance to teach functional programming. By golly, it was time they're going to do it again. They could only get something interesting. Well, they needed something special this time, and they couldn't be outdone by Lord Crimson or any of the other lemurs. To do that, they needed to go deep in the furthest reach of the library, where all the real fun books were hidden, where light begun to fade and the magic around them swirl crackling in the air like stars in the sky. Now, what was the best sign something was truly fun? Well, of course, the more locks and chains and everything else, the better. If Violet had gone through such great care to make them that locked away, then that's exactly the book they want. So kind of her to make it easy to pick, very considerate, no? And in that Forbidden Cove, there was one book that stood out, marked with the sacred lambda symbol and under the protection of lemurs from a very foreign land far away from Ruby. One sealed with ancient magics, binding spells, and locked tightly in chains, and on its cover we can faintly make out the text Wonderworld. Upon opening the book, a blue fog emerges, the air in the room stirs, and all lanterns extinguish. There are deep magics here, secret design patterns from lands of functional programming, very different than what we might know from object-oriented languages. There are functions, mappable and reducible types, and something else beyond even that combined everything. A name which must not be spoken aloud because who cares? Rules, rules, rules. Who in the world reads all these warnings anyway? But the rest of this book? Oh, this is perfect. Indigo cackles himself, delighted, discarding all the warning notes and warning spells as he exclaims. But they heard a noise, a soft thump of slippers, and light coming around the corner. The master library, Violet, was awake. She entered the deeper library, lantern in hand, trying to figure out what in the world was going on and why so many alarms had triggered. There she found Indigo and the Escher cat with a particularly dangerous book. What exactly are you? Violet was cut off. Escher, time to make an exit, whispered Indigo. Violet, annoyed, yells out after him, Indigo, Escher, don't you dare! We cannot have another instance with eval or metaprogramming. So the Escher cats smiled mischievously, and with a snap of their paw, the two began to make their mischievous getaway, fading out into dust. Violet sighs, Goes to the place where the book once was, seals undone, multiple months of binding spells broken. The one book which must never be opened, the one subject which must never be taught, that will render its reader incapable of ever teaching it again. A subject no wise lemur would ever dare touch, lest they be banished to the faraway lands. All that remained was a scribbled note and a smiley face and a quickly drawn thanks. So Violet takes a moment collecting herself as shadows behind her stir and coalesce. Behind her, the figures of several hoods drawn over their faces, the owners of the book from the distant functional lands. They point to the missing book, and the head lemur simply says, "It must be found, for there are some things the lemurs of this land are not ready for, and something which must not be unleashed within its pages. Once before, Lord Crimson visited our lands to learn from it, but even he was not foolish enough to teach it here. The words must not be spoken." Vlad agrees to this. Yes, we can only hope it can be retrieved before that thing is let loose upon the world. An ancient creature from time immemorial, granted with some terrifyingness potential, who cannot be comprehended by the normal lemur. The only question left was where Indigo might unleash such a force, and what, if anything, could be done to stop him and the Escher Cat. They could only hope no one would be caught up unaware in such a catastrophe. New adventure. Speaking of unawares, we find our friend Red the Lemur studying in his tiny forest grotto. He was just finishing up his book, searching for his next alignment, but he always found himself returning to the classics. He sighed and looked up to see Saffron, the great tailor, sprinting right on through with bolts of silk over his shoulder. As he dashed, and he heard him repeating something about tea parties and needing to be early. A piece of paper slipped out from his bundle and landed right in front of Red. Early, early, early. Why was he so obsessed with early? This is about a tea party. Red was confused, sat down his book, and began to chase after Saffron. Wait, where are you going in such a hurry? Saffron asked Red. So many outfits, so many costumes to make. I need to get there early before the party starts. Anything through VVVIPs, yelled Saffron as he blew on by. What tea party? Asked Red. Check your invitation. They insisted you be invited as guest of honor, said Saffron. So Red took a moment to take a look at the invitation. Saw what appeared to be a scrawl of crayon with arrows pointed at what looked like a staircase and when he looked up, Saffron was gone, and in front of him was a giant tree with a hole in its center, and a suspiciously well-designed sign that read Fantasyland. Was it a trap? Probably. Did Red particularly care? Probably not. There's far more fun in exploring and pushing the limits rather than standing still. He wasn't going to miss out whatever this adventure was for the world. So he found himself climbing through a labyrinth of stairs, right side, left side, upside, downside. Which way was even up anymore? He found himself more and more lost, but at the same time approaching something until he found himself at a gateway to a strange new land. Force of functions. Upon exiting the strange labyrinth, he finds himself in a strange forest, unlike anything he's seen before. And in that forest, he can see a fire in the distance and a few familiar voices. The masters, Lavender and Crimson, were sitting by the fire, drinking tea. I was told Indigo was up to something big. You think we should put a stop to it? He heard Lavender saying. Why? It seems interesting so far, and who knows what else him and that cat came up with, said Crimson. It appears we have a guest. Shall we serve him some tea? Just, not a party. We shouldn't interrupt those of later. Red emerged from the forest, confused, and asked, what in the world is going on in this strange place? Two looked at each other and began to laugh, and Crimson answered, it appears our friend Indigo and the Escher Cat are having their fun, and they've been so kind as to involve us in their little plans to get you ready. And also to supply tea for the little party. Red looked confused at this. To start out with, what is a function? A lambda or proc, right? Strictly speaking, yes, but what are they used for? The problem in Ruby is that we see it as almost a foreign part of the language, but in my adventures in lands of functional lemurs, I learned something else entirely. What do you mean by that? I mean that with only functions, if you're so inclined, you could build entire programs by gluing them together. Shall we take a look? Let's get started with some basic functions. In Ruby, there are a few types of functions, but generally they're categorized into two types, lambdas and procs. In this talk, we'll be focusing on lambdas when writing explicit functions, but there's another case we'll get to shortly where procs are a little bit more common. Functional programs work by gluing together smaller functions to do more complex tasks. Ruby provides us with just the glue to do it. In this case, we have two functions, one which adds 5 and another which multiplies 3. Ruby can glue these functions together using something called functional composition, which functional programmers will call composition. In this case, we can glue add 5 and multiply 3 together to make a new function which does both. We can see this by calling it. Now, you might think, why do I care about functions in Ruby? I'm never going to use that. Well, you already use them, and they're everywhere in Ruby. This probably looks familiar, and in fact, it is a function, perhaps by a different name, but block function, they're all functions, and you're already using them everywhere in Ruby. Block functions are actually procs under the hood as well, showing us what that second type might look like. Now, if we wanted to, we could even make our own methods which take a block function, like let's say select. Implementation might look a little bit like this. Shall we go ahead and step through it? In this case, we call it a predicate function because we care about whether it returns truthy or falsy. Really, we can name it whatever we want, but that name seems to fit well. But the question is, what's it being used for? Well, in this case, we use it to find out which values in an array are even, and then we add them to a new array which will return from the method, giving us only the values for which the predicate function returned a truthy result. Now, as to how that would work, we can take a look at how the values would flow through select step by step. For our first value 1, we check if it's even. It's not, so it does not go into the new array. For the second value, 2 is, so it does go into that new array. And the third, 3, is not even, so we do not add it to the array. This leaves us with our final array only containing 2. But one thing to keep in mind with Ruby is there are many, many, many ways of doing something. Which one's more correct? Longhand? Shorthand? Select? Filter? Well, it really depends, doesn't it? What answer is correct depends on the code base you're working in and the people you're working with. And first and foremost, to be understood and not clever. Beyond that, there are many lessons from many other languages, some very different philosophies than what you might find in Ruby. All are valuable, certainly, but be careful not to become dogmatic, said Lavender. And with that all said, there are others to meet, lessons to be learned ahead of you from friends old and new alike. So read on towards the next area. You think we should warn him about the... Lavender was cut off. Nah, it'll be more fun if they learn themselves, answered Crimson. Part 3, the Mappable Meadows. So we find Red entering the Mappable Meadows, a place filled with flowers and plants of all kinds. There ahead, he finds Chartreuse, his teacher from many years past, that taught him the ways of map. But this is a different place at a different time. It's been what now, 6 years? My, how time flies and young ones grow, and so too does our understanding of what we think we already understand. What do you mean, Master? Last time we spoke, you taught me about map, but wasn't implementing it with reduce all there was to learn? What is map exactly? Well, of course, it's using a block function to transform every element in list, isn't it? Yes, that's true, but there's far more to it. Let's take a look. To start out with, we'll take a look at map. Consider this example. We know that it can double every element of list by applying a function that takes a parameter v and returns v times 2, but how do we know it does that? How do we know that this block function will double every element in list? For an array, it might look like this, certainly, and in doing so, we might notice, interestingly, we also return a new array. An array in, an array out, if you will. That's because mapping in the context of Ruby's array means to return a new array, with every value transformed by the function we provided. What if this were a different type, though? I'm not entirely sure. Let's suppose we defined map on a string. What might that look like? The way we define map changes depending on the class and the context we're working with. Perhaps in the context of string, map would make a new string by iterating through the characters of the old string and transforming them, adding them to a new string, which we then return at the end of the method. And we would call it maybe something a little bit like this, giving us something that looks very similar to a map function we made for an array, but I think we can go a little bit further in our explanation. Perhaps we could define our map function on string itself. Much like array derives map from enumerable, we could define our own map directly in the class. I would not suggest doing it, except as an example. Now, the notable difference here is that we're getting characters directly from self, which, while not required here, does make it clear where it comes from. The other is that we're directly calling map on the string itself. Which gives us something a bit more ergonomic, but we can go further. We can implement map using map. So if we took our original code from before, we could instead use map to implement map. Now, there's certainly no rule against it and would shorten our code a good deal too. The two differences are that now that we're using map, we're also using join to join the characters back together. In fact, we could go even further still and condense this a little bit more using shorthand. So we can take our current code, and we can shorthand and pass the function directly to that new map we're calling on string characters. Now, that all said, we should probably not monkey patch core classes, right? That's not very in trend now anymore, is it? So what other options might we have? Well, modules might be a good start. What if we started there? So taking a look at this, we can take our monkey patch class and extract it into a new module that will look very similar to what we already have. Now, there is a problem here, is that if we want to use map more than once, it quickly becomes unwieldy, doesn't it? So we're going to need to find another option. What if instead we wrapped our string in a class of our own making? A class to be our own custom context where we get to define the rules of what we want it to be. We could even define map on it, but this map has a problem. It returns back a string, meaning that this code would break. That's because we went outside of the context of our class and returned a string instead. It's no longer a string characters class, it's just a string. So what is one to do then? How would one get around this inconvenience? Well, we simply need to bring it back into the context of our string characters class. What if we introduce the idea of wrap to do just that? It's a way to take a string and put it in the context, or bring it back into being a string characters class. To use it, we would add a wrap around our implementation of map, and it will work just as we expect it to. But there's one thing to keep in mind. The value is still in the context of our string characters class. We need to get back out. Have our own rules is great, but our program and our users probably want a string instead, don't they? So we should probably get that back out. Well, we can do that by calling value on it. So taking a look back at our implementation, it looks like we have something which could be used elsewhere, no? Like wrap and the idea of value. What if we pulled that into a new module? Let's call it something like mappable to represent something which could be mapped. Basic example for making our own context, but it serves a point. By doing so, our implementation of string characters is shortened to this. But what's also more is it can also allow us to do maybe a simplistic version of string words, where we iterate instead of characters on the actual words, or maybe even string lines. The point is this behavior is very repeatable, and by establishing our own way to make rules for map, we can do things that may not make sense for classes like string or array. We could even use this idea if we were to use it something completely different, like let's say, take this single white flower here. Could this also be mappable? Perhaps in the context of a flower, the color is what we want to change. Mapping the context means to transform the color and return a new flower. We could even add rules to define what a valid flower is by checking if that value is a color. An easy mistake to make is thinking map only works on collections. Not so. It can work on context, and a flower is just as much a context as an array or a string might be. So to test this, we would take colors white and red here and create a new white flower, which we mix 0% white with 100% red, effectively painting this flower red. So there was a song once I'd heard about painting flowers red, but that's neither here nor there. But now that we have an idea of what it means for something to be mappable, there are also a few rules we should keep in mind, ones you might have already noticed the reason for earlier. Now, there are 3 rules we need to keep in mind for things which are mappable. Rule 1 is if we do nothing to something which is mappable, it should, unsurprisingly, do nothing. We start by defining equality in our mappable module. For something is mappable to be equal, it should be the same type as well as have the same value. So let's take the example of the string hey world. Make ourselves a do nothing function and add a new string characters context here. Afterwards, we want to check if doing nothing does in fact do nothing. We're greeted with a true response. This means that doing nothing in the context of something which is mappable does, well, nothing. So why do we care about this? That seems very simple. Back to our module context with our string characters class before map, these would have failed. It means that we're not returning the same type, and that we can think of this as a baseline test to ensure our mappable class works as expected and we retain the same types in the same context as we're going along. Rule number 2 is if we call map twice with 2 different functions, we should get the same result as if we compose the 2 and call map on it once instead. Like, let's say that we were to try and get something to wrap characters in brackets and something to get the next successive character. We could even create our context again to experiment with, and then prove that by testing if mapping twice with each function separately returns the same as if we compose the 2 functions. Why do we care about this? Because after all, these are just functions. We're not changing the rule of how functions work, we're changing the rule of how our string characters class works. We should not be doing anything unexpected to functions. Or more simply, we do not wish to surprise people using it. What you see is what you should get, no surprises. Now, we may be able to define our own rules, but functions also have rules, and we should be careful not to break those and do unexpected things. Though, in some cases in Ruby, this does not hold true, such as hashes. Have you ever noticed that? Have you tried calling map on a hash? What do you think happens? Ruby's hash does not behave this way because it inherits map from enumerable, not from hash. That returns an array instead. We must be careful of this, but Ruby's hash also has another method, which is very interesting, which is toH. Did you know that also works very interestingly like map? Does it mean we should change map on hash? No, not quite, because too much code already relies on this behavior, and changing it might be dangerous. So you see, Red, there's far more to map than appears, an entire world of mappable things to discover out there in the wide world of Ruby. We've only covered a small part of their potential. Consider it a pattern to be used when you find things in your programs which might have similar shapes that follow those rules. It's all fascinating, but where are we going with this? Why learn about context and values and mapping? I'm confused where this is all going. That. Now, that's a lesson you'll be learning soon enough, but it's not my lesson to teach. Journey on to the tea party, you'll find the answers to your questions there. So with that, Red had learned more about map and began to walk on to his next destination. The reducible residence. As colors transition from greens to golds, Red finds himself on the path to a tailor shop on the edge of the forest. But the tailor shop looks almost exactly like the Lavendervale tailor shop owned by Saffron, but how in the world did he get here of all places? So Red went to take a look. There at the end of the path, he sees a little shop with various outfits, fabric littered everywhere in an eclectic smattering. Saffron had certainly been busy, and just then Red saw Saffron bolt inside the shop, fabric flying everywhere behind him, still droning on about being early for the party. What party? Why was everything so early? So Red enters the shop. He finds Saffron hurriedly finishing several outfits of cuts and styles of fine party suits, imperial dresses, and even a hat for a cat. So he had to ask, what in the world is going on here, Saffron? I'm preparing for the party, of course. I am a lemur of my word, and I have a reputation for promptness to uphold, Red, Saffron stated proudly. Well, I suppose I'll be on my way then. If you could just point me to this party, I'll be out of your hair and up. Saffron stopped, turned, and smiled. Oh, no, you don't think you came all the way here for no reason, did you? Come, back. You're going to help me. And to do that, we're going to need to teach you about what it means to be reducible. Red flinched, but before he could make for the door, Saffron was already starting into his lecture, and it was too late. And what better way to start than to answer the question of what does it mean to reduce? Of course, we have a reduce method in Ruby, but it's not often used directly. Like, if you've ever used this reduce syntax, it's going to look very odd indeed. But what happens to the array? What's the zero? What exactly is that block function doing? What's the reason for all this? Well, let's step through this real quick and take a look at the values of a and v for each step of reduce. We start out with our base case, 0 as the first argument to reduce. While we name it a here, it stands for accumulator. Then we take 1, our first value in the array, as v. Then we combine it with our current accumulator, which gives us the result of 1. So what exactly do we do with the result of that? Well, we bring it back, and now we start the loop again with our last result becoming our new accumulator. And then 2, the next value in the array, gives us back 3, which we then bring back again and run one more time to get back the final value of 6. And that would be the value that's returned from reduce. So taking a look at it from the top, we're doing exactly what we mentioned earlier, adding 0 plus 1 plus 2 plus 3. Or more accurately, we're combining in a leftward direction. Now, given that it's not surprising some other languages call reduce another name entirely, which is fold left. But isn't that just the same as sum? Why go through using reduce then? Asked Red. Exactly right, but why? There's something very interesting here to explore. Ruby's sum method is far more common than reduce. It simplifies a lot of what reduce can do. It's the same as saying 1 plus 2 plus 3, or is it? You see, there's an interesting property here which might look familiar. What happens when you sum an empty array instead? If we sum nothing, what exactly is the sum of nothing? As it turns back, we get back 0, that empty value we mentioned earlier. So in reality, sum is doing something more like this, or condensing it back down. 0 plus 1 plus 2 plus 3. Now, this is fascinating, but why does it work? What magic is afoot here which enables this? Well, to explain this, we're going to need to do math. Not much. I don't like math, so we're only going to do a little bit. So if we add 1 plus 2, we get back 3, but there's a particularly interesting number in which if we add it to any other number, we get back the same number. What number might it be in the context of addition, do you suppose? Exactly right. It would be 0. In the context of numbers and addition, the empty value would be 0. But let's say we change the context. We change the rules slightly. We're no longer adding numbers, but we're multiplying them instead. And this would give us back 6. Now, given that, what value here would reasonably be empty in the context of multiplication, do you figure? Could it be the same as addition? Exactly right. That wouldn't work at all. So what empty means is very dependent on the context of what type it is, what we're working with, as well as how we choose to combine them, whether it be multiplication or addition or maybe something else entirely. In this particular context of numbers multiplication, that empty value would be 1 and not 0. And we have things working again. So we can add numbers together, great, but is that all it can do? Who said it only applies to numbers? There's certainly other types which are reducible as well. Now, we already know about these two, in which we have an integer 0 and plus, and an integer 1 and multiply, as far as ways to define empty and the way of joining these two values together to be reducible. And we can even use them in this shorthand now that we know it works. But reduce goes beyond that. It's much, much more powerful than just summing numbers. Like, let's say we happen to use strings, an empty string and plus, or maybe we use arrays and plus, or hashes, empty hashes and merge, just to see how that might work, along with a few demonstrations. So this pattern is far more useful than just numbers, isn't it? Now, one you might not expect, functions are also reducible via composition, and an interesting function which returns whatever its argument was. Just remember that left compose goes backwards of what you might think. And if we were to flip it around, if it were just addition, we get the same result. But in the case of order, it does matter a lot. Well, for adding numbers, it's the same. But this direction is probably more familiar to you as someone in Ruby than it might be for Elixir programmers who use something called pipe instead. So this pattern is perhaps generalizable, wouldn't you say? Perhaps we want our own version of something which is reducible, much like mappable. To do so, we would need an empty value, a way to join two values, and for convenience sake, a reduce method. So let's say that we have our integer sum here, which has an empty value of 0, a way of joining, which is plus, and reducing, which just calls that join on top of empty. If we happen to flip that around, we could say that empty is 1 for product, and joining is multiplication instead. But you'll notice reduce doesn't change here. But we could go a little bit further, couldn't we? It's actually making something reducible as an interface. Now, we can do this much like what we did with Mappable. The difference is it applies to many things rather than one thing. So it's not something which can be included in an instance. We'd have to instead extend. In this case, we already know we can add integers with plus, so we don't need to overwrite join or reduce, but we do need to define what empty means in the context much the same way as we would need to define empty in the context of multiplication. We would also need to redefine what it means to join two items together in this context as well. But as with Mappable, there are rules to observe here on what makes something reducible. The first rule is that for a given type like numbers, we need a way to combine two numbers that gives us back another number. Why is this important? Because we can't predictably keep combining things if the types are not the same. The second rule is that as long as we retain the same order, we can group these additions or joins together however we want and get the same result. Now, why does this matter? It means that we can save intermediary results in a variable, or if we really wanted, we could parallelize the operation, just need to retain the same order. Now, someone particularly clever might note that for addition, order doesn't matter at all, but that's a step beyond what we'll be focusing on today. The third rule is for something to be reducible, there should be an empty value of the same type, that if you combine it with any other value, you might get that same value back. Now, why does this matter? Because summing an empty array, it matters because we have a reasonable default to fall back on in the context how we're joining things together. Can you imagine if enumerable didn't give us back an empty array, if we got elements out of select, let's say it raised an exception, it would be chaos. We'd have to program Java again. Now, let's try with a more complex class, like say move. Now, this can be represented as movements on a grid using data.define to make a lightweight class. We can create a new move like any other class, but we could also make that reducible. And we can also use this shorthand with array brackets. So given that it extends reducible, it means that we also have a reduce method which we can use here as well. But the question is, do these rules hold? Checking on it, we can see they do. We can combine moves, group them, and we even have an empty element to boot of move 0, 0. Now, let's say we did something a bit different, a representation of time on a clock per se. Does this also hold the same patterns? Now, time is interesting in that as soon as a clock gets to 12, it loops back around to 1. If we define addition in such a way that we use modulo 12 to have it loop back around, if it ever has value over 12, it works. The rest probably looks similar to past examples, and you would be very right in saying so. If we were to test the rules, we'd find out the rules hold for this example as well. So, as you see, reduce is a very powerful idea, and the idea of something being reducible could apply to a great many cases. It's all fascinating, but how in the world do you have an exact replica of your tailor shop here? Asked Red. Saffron chuckled and said, I made Indigo and Escher Cat earn that VVVIP status. That's how. A few more rush orders like this and I'll have 20 shops. With that, Red sighed and left the shop. No sooner than he left did there crackle a little bit. An Indigo and Escher Cat emerged from the closet in a cloud of dust. I'm afraid your aim needs some work, dear Escher, but we got there all the same, so thank you, friend. Now then, are we ready for the tea party yet? Anything for you, sir. Come right this way, and we'll have you off and about long before Red finds his way to the party. I made sure to add a small detour to your map, just in case. Oh, you are naughty. I like you even more now. And I hope you like these outfits as well. Saffron opened the closet, and Indigo Escher Cat stared wide-eyed. You, sir, are a master. Put it on our cards. The tea party. I would definitely suggest scanning this one. Firstly, because I need a short momentary break because it is very warm up here. Also running out of pages. There we go.
we find ourselves in a forest, but something feels wrong here. We find Red very lost trying to follow the map and the signs, but this forest, it belongs to a particularly mischievous cat named Escher. Where have I ended up? Surely I passed the same tree many times already, said Red. As he grumbles, we see the Escher cat subtly, slowly, changing the signs around whenever Red stops paying attention. Always just outside, always gone right before Red turns around to look. So we see Red turning and fretting and wandering until right at the edge of the forest, we see a thumbs up and the Escher cat smiling somewhere in the ether. So Red whipped around to see the Escher cat flipping a sign, but the Escher cat wasn't the least bit bothered by this, casually flipping the sign and grinning from ear to ear, tapping away at the sign. Now hold on there. You've been leading me around in circles for at least the last hour, and with a wink, the Escher cat disappeared, leaving a sign pointing towards the path to the end of the forest, illuminating a strange glow. Well, we certainly could have started with that. Now then. And with that, Red entered. So many lemurs and old friends, new old colors and studies, celebrating a tea party prepared by Lavender, and all turned to greet him, cups raised high. They all said, "Welcome to the party, Red." And then they turned to roll the drums, and behind them, Indigo descended on the main table, floating down from the sky with an umbrella and landing in a puff of smoke. A merry young conference to you, dearest Red, a merry young conference indeed. We've been expecting you, young Red, and my, how we waited for this. Hey, come, come, come. So Red walked over to Indigo. I do hope you've had fun so far, and I assure you every bit of what you've learned so far is in fact very necessary for this next lesson. Wait, you mean all those things are related? You weren't just wasting time? Yes, yes and no, but you'll know more as we dive further. Shall we get started? Let's start with the idea of something being falsy. So consider this code for a moment. You want to cache this, but what might you do? What's your first instinct here? Consider that for a moment. In most cases, in Ruby, you might want to do something like this. But there's a problem here. Can you see what that might be? Exactly. What happens that API method happens to return false, and false is a legitimate result. Even worse, what if that was an expensive call which happened to take 5 or 10 seconds or something like that? Then you have a very annoying bug to track down. As it turns out, context is a very useful thing. In this case, we can use the context of the ready-to-brew instance variable not being set yet to determine whether or not we should call the API to get a value. Without that context, we have a false value. Why wouldn't we try again? It makes sense to. Now consider HTTP responses for a moment here. Let's say we had a response with some JSON and response code of 200. Just looking at the body, we might be able to guess whether something was successful, but with the status code, we don't have to guess because it gives us just enough additional information to make decisions based on what it is. Should we process the data or should we be handling errors? Well, now we know. But what if something happens to break those rules? Like, let's say normally when we get a response back for 200, it guarantees success, doesn't it? So I wish. What if someone were to do something naughty, like return an error with the 200 status? Now, it sounds silly. You might think, who in the world would do such a contrived thing? But GraphQL does this explicitly. But it might still make sense because the request to GraphQL was successful, but the body inside of it unfortunately did not make it. We apologize, but you have a 200 error. Granted, no guarantee at all that the context inside the request is going to be what we expect because things are complicated, unfortunately, in programming. Now, if we had no additional context, no status codes, or even unreliable ones, how would we say what part is successful or not? What does it mean to be successful? For a few examples, this isn't a problem, but say you had 100 or even more, or 1,000 more. Let's say that you had patterns upon patterns in a monolithic Rails application which happened to span millions of lines. Maybe some of them like empty hashes. Maybe someone like JSON. Maybe some like empty strings. Maybe some like raise an exception. Or maybe they don't raise an exception. They just return a string with an error inside of it that you then have to parse and know what in the world to do. Maybe they return number codes. Maybe they're using protobufs. Maybe they're using God knows what other pattern they saw in Hacker News yesterday. It's madness, I'll tell you. What a quandary. So what do we mean by failure then? How do we have a unified definition of what it means to fail? So Maybe failure is an exception. Maybe it's a custom class. Maybe it's false or nil. Or is it? Or maybe it's reasonably empty. It could be any of them, or it could be none of them. It could be something else that we've yet to invent. You don't entirely know. But what if we had our own idea of what a result was? What if we could write our own rules, have our own definitions of things? But unlike the other wrappers, this has two parts. The first would be the idea of success, which has a value and a few Boolean methods to tell us whether or not it was a success. We could even make this class into a class method to make it a little bit easier. But on the reverse, we'd also need an idea of failure. Why two separate classes? Well, all in good time, but this gives us an interesting base to work from. For a basic example, we might have a method to get data which returns either a success or a failure, depending on the status code. And we might use it a bit like this. Looks familiar, doesn't it? But we're not really done with that. No. What if our idea of success happened to be mappable as well? What would map look like on something like this? What do you think it might look like on a success? Consider that for a moment. We could return another success and use the function to transform the value inside of it. But wait, it does get a little bit more interesting here. With failure, map might look very different. Do we still need to transform the error inside of it? What exactly might this look like? Well, in this case, you don't have to do anything, nothing at all. We return the current failure, effectively ignoring it. Nothing tells us we have to do anything with map. There's no rule about that. That means that if something returns a result and we call map on it, it was a failure and we don't have to worry about doing anything to it at all. So looking at our previous version of the code, we can now absorb the success branch and get rid of this conditional entirely into our new map method. If we're successful, we get the data and this will be called. Otherwise, it'll be handled by the failure branch below. This means we just absorb one part of that conditional into our result type, all with the power of mappable. But what if we wanted to absorb the other half? What if we don't care about the error at all? If we had to make a method like value or to give us a default value, what might it look like for a success? Well, just the same as failure does nothing. This method would just give us the value back because we have a successful value, so we do in fact have a value. But in the case of failure, much like map, success and failure do opposite of each other. So in this case, a failure has no value, so we instead would return the defaults. So we can take a look at our previous code. And if we don't really particularly care about that, we could say value or, and then hand back just a simple hash. No conditionals needed. Now, this is all fascinating, but this is my favorite part. What if something happened? What if we had something that was a success, but whenever we use map on it, it returned another result entirely? Let's say that we order tea and we want to ensure that it's a good deal for the price and for the quality of the tea. Perhaps if the tea is rated on a scale of 1 to 5 and we consider $3 fair for each level of the quality, we consider the tea too expensive. In the case of a good deal, like 5 out of 5 quality and a good $14 price from Honeydew and Daughters, we would call that a success with about a 2.8 ratio. But wait. We have a success inside of a success. That can't be right. Something's broken here. Let's try one more time, just to be sure. But maybe we have an otherwise lovely tea from Forest Mango, but $10 for a 3 out of 5 quality is just not justifiable for our tea parties. No, so what happens then? A failure inside of a success? No, this won't do it all. Something needs to be fixed here. Something is broken. We need something else. It looks like we need another method that returns a result. We can't return that from a map now, can we? We need something else. Say I wanted to put tea into my cup here. Would I put the entire teapot into the cup? That wouldn't make much sense. It wouldn't fit. Of course, right. It makes no sense. So what if instead of putting the entire pot in, which makes no sense, we pour the tea out of the pot into the cup? We know the tea is inside the pot, so we just as easily pour it into a new container. And the same idea can be applied to a result as well. Our pour method here is very much like map, except maybe we don't want to wrap the result in a success. So what do you think that might look like? We simply remove the wrapper. In fact, we could even implement map using pour, along with our entire earlier wrap from Mappable. Even more interesting is we're effectively joining two successes together, which may sound very familiar to reducible as well. And if we use it in place of map, when we know the other method will give us a result, we find that we only have one layer of success to deal with. But what about failure? It's not doing any wrapping for map because map really doesn't do anything. Turns out, same is true for pour. It just ignores it and returns. If we tried to use it, we'd find that as long as the result before is success, that it can give us back a failure. Fascinating, isn't it? Never thought I'd learn lessons from a teapot. Wonder what happens if we try and HTTP request that thing too. Surely nothing bad or unusual would happen, right? I mean, we're all mature people on the internet. You know, I've never actually tried this. What do you suppose happens whenever I make this request? Wait, why? Who comes up with this? Why is it a teapot? I know it's a teapot, but why does it know it's a teapot? That's rather deep, isn't it? And what's a hypertext coffee pot control protocol? This place gives me headaches sometimes. But that gives me an idea for a similar example. What if we made our own teapot and made it pourable? What does it mean for something to be pourable? And what does it mean for that to also be mappable and reducible? Well, it turns out a lot. So let's start by making our idea of a pourable interface and see how the teapot might implement it. Remember back, this is what mappable looked like. Well, given this base, how might pourable come from it? As it turns out, something which is pourable is already mappable. We could even implement map by using wrap and then pour method if we wanted to. How is this reducible, you might ask? Well, we'll get to that in a moment once we cover the rules, but you might already be able to spot it. So let's say we made a teapot which is pourable. If we use map on a teapot, we get back a new teapot with the value inside of it transformed, which is the base of something being mappable. Wait, pause, time out. Teapots have tea inside of them, not numbers. That makes no sense. What are you doing here? Well, that's because it's my teapotty. If I want numbers in teapots, I can't have numbers in teapots. It's called Fantasyland, not Rubyland. Anyway, moving on. Him. And if we have a method which returns another teapot, we can use pour to combine the two of them and get back a new teapot. Wait, combine? That sounds a whole lot like something which is reducible, doesn't it? You remember when I said that something which is pourable is both mappable and reducible? Well, here's where you figure out exactly how it's reducible, and we're going to do that using some rules. So the first rule we have to consider here is left identity, but let's call it join for now. Join's a little bit more accessible. Put simply, it means we can combine two pourable things, but how does it work? If we pour a value onto a function, we get the same value as if we called the function directly. In other words, we have a way to combine two things which are pourable, in this case, two boxes. Combining two boxes gives us back another box, which sounds very similar to combining two numbers, getting back another number, doesn't it? Update my notes. So in the other case, we're calling add5 method directly with number 5, rather than pouring the result out, that also gives us back a new teapot, which has the value 10 inside of it, which can prove works here. Two teapots with the value 10 inside them are indeed equal to each other. Why is this important? Well, we want to be sure there's no funny business that happens if we pour a value out of our teapot. If we use the same value that was inside the teapot directly, like 5 here, it should be no different than if we poured the same 5 out of our current teapot into the new teapot. What do I mean by funny business? Well, maybe someone thinks we can invent more tea out of the air. How preposterous. Can't be done. I should know. I've tried. Escher has too. These types of shenanigans will definitely fail our rule. Now, the next rule is right identity, though we can also call it empty, much like reducible. We start out with a new teapot with just the value 5 inside of it, and we pour it out directly into a fresh teapot. So it makes sense if we were to put the same value in a new teapot, they should be equivalent, right? Why is this important? Well, it means that when we make a new teapot, nothing funny is happening on that side of things either. A fresh, new, empty teapot should be clean and should not do anything surprising to the lovely tea we just poured into it. No, no, no. The last rule, associativity, is the same idea of grouping from earlier. It means that there's a very similar functional composition to mappable too. Isn't it fascinating how some of these ideas are overlapping? Say that we had two methods, both which modify the values before putting them into a new teapot, like multiplying by 2 and adding 5. If we're to take the initial teapot and add the value of 5 inside of it, and then the result of directly pouring them each into each other in the same sequence should be the exact same as if we poured the original result into the multiply 2 method, and then poured that into the add 5 method inside of that original pour. Now, we can see these values are equivalent, but this rule in particular may be hard to follow. Look back at this from a different angle, and it may make more sense. However we choose to group these additions, we get back the same result. The same is true here. But if we happen to replace plus with pour instead, we start seeing something very fun indeed. Why is this important? Well, very much like things that are reducible, isn't it fascinating that we have all the same ideas come together? Something that is both mappable and reducible at the same time. I think we might have discovered something fun here. But Red, I am a naughty lemur, and I've been lying to you this entire time. I feel I must come clean to you and tell you what this has all been about. But first, there's someone I feel you should meet. With that Indigo gestured to an opening of the forest, a horrifying red fog emerged. Eyes of flame growing bright. So it approached, waffling through the woods, burbling as it came. The jaws to bite, the claws to catch. Now he must run, or Red would face his match, except the fog dissipated. And in its place was a small green cat with dragon scales meowing happily. It is my great honor to present you to our new best friend and creator of these lessons, the Monad Walkie. You see, I wasn't entirely being truthful about all the names for these things earlier. I do apologize, except I don't. So, mappable was the idea that you could map over something while retaining its same shape. It's true, however, it's a functor. The idea that you can map over a context, whether it be an array, hash, promise, active record, conf, or much of anything, really. Though map might also be called fmap, standing for functor map in other languages, and wrap is sometimes called unit or return, not that return, or sometimes even of. Reducible was the idea that many things could be combined into one thing. The same is true. Its true name is monoid. Mono meaning one, oid meaning in the manner of. It's the idea that many things can become one thing. And some of our methods might also have other names, such as reduce is sometimes called fold left, join is sometimes called mconcat or empty or concat, and empty is sometimes called identity or m0. And pourable? Oh, that's a fun one, but you probably know where I'm going by now and what I've done. Its true name is monad. The idea that something can be both transformed and combined at the same time. What's funny is you've already been using several of them. Enumerable? Yep. Active record? Also yes. Builder patterns in general, pretty much. I mean, sometimes I'm sure the lemurs might take issue with my descriptions here, but this is my tea party, and we're aiming for only close enough here. And actually, these ideas have their own name. Wrap is commonly used with monads, but it's often called unit or return. But again, not that type of return. Pour, something I completely made up. Its real name is bind or flat map, with the occasional use of the bind operator you might see in Haskell there. What's more fascinating is that then in Ruby is almost a variant to find bind in itself, if it behaves well. Wait, so that's it? I thought those were supposed to be terrifying and impossible to explain. It's just a small cat? That was the monster? That's anticlimactic, isn't it? They are very cute, though. But didn't you gloss over a whole lot of detail for monads? Didn't you skip a lot? Oh, who cares? It's close enough to make the point. They're not all that terrifying. This is my tea party, and now it's over. No one can do a thing about it. After all, monads are just monoids in the category of endofunctors. There, I said it. What are you going to do about it? Except I still have time left in this talk, and those mysterious lemurs from earlier are not ones to be forgotten or to let things go. No. Especially if Indigo goes off and says something like that. The mysterious lemurs. So the purple fog emerges again, and the same group of mysterious lemurs comes forth, summoned by those very words, the words which must never be uttered, and whisper could be heard all around them. Monads. Endofunctors, just functors in programming. They skipped a plicative functors. They must learn properly. Indigo breaks out in a cold sweat, for he knew exactly who these lemurs were and exactly what they were here for. They were lemurs of Haskell, And they had come to, oh, Indigo, you should have let us know you wanted to learn about monads. We'd gladly teach you. There's so many reference manuals and fun lessons and things we could take you through, and so many rules to explore in the Ivory Tower, right? Oh, man, I can't believe that you volunteered for all this. But, no. And of course, now that you've opened the book without reading the terms and conditions, you simply must come. Rabbits, dodos, flowers, jabberwockies, and... Oh, no. This won't do it all. Indigo begins reading the book looking for a loophole, but finds a binding spell beyond his ability to break had already activated. Anyone who's seen the Monadwalkie must be taught the ways of the Ivory Tower, lest they try and do something irresponsible, like teaching others about it before they're ready. Right, Initiate Apprentice Indigo? Outro. So we find the Elder Master Lemur World still sitting at the tea party. Are you sure that was entirely kind of us, Crimson? You know how lemurs of Haskell are like. It'll be good experience. They're eccentric, sure, but we ruby lemurs aren't much better if we're being fair. No. The point is that those two got to explore a brand new world and find all sorts of new adventures in them. But I don't get it. Violet's normally so protective of her library. Why was that book in particular unlocked? With a familiar crackle and pink sparkle, Violet appeared in Indigo's chair, chuckling, tea in hand. It was about time for Indigo to learn a few lessons, and who better to teach but them? Now that's just mean-spirited. I'm the Dark Lord here. Violet continues to sip tea, smiling to herself. Who said it was my idea? The Escher cat sat in her lap and simply purred. Isn't that right, Escher? So Red and Indigo were initiated into the Ivory Tower, Bastion Functional Programming, in the home of lemurs of Haskell. There they learned about certain topics like category theory, monads, applicatives, and more. Red was certainly excited, but he could hear Indigo complaining about never opening another trapped book again. So we find the book safe, locked away again, deep within the library. But in the world of lemurs, there are many more hidden books, secrets to discover, knowledge is considered forbidden, or just too plain strange to learn. We can still find them if we look hard enough. But while they may seem strange in nature, the lessons we learn from them may well inform how we program Ruby in the future. Many of those lessons have already escaped this library, like pattern matching, functional composition, reactors, and more. What was once fantasy became reality. And what was once thought as strange became normal. So we endeavor to explore and find out what's possible, whether from Ruby or another language entirely, who knows? But we must always continue to venture out and learn, even from the most unexpected places. What is considered forbidden today may well become proper Ruby in the future. And as we grow, so too does Ruby grow with us. So, just to wrap up, if you want to read any more of my work or examples or follow along, feel free to find me on any one of these social networks. But, of course, with this much art, I had a lot of folks to get inspiration from, and tutorials that really helped bring this vision into reality. As well as a significant number of technical reviewers I've had over the past few months who helped me go over the code and content from this talk. Anyway, that is all I have for today. Thank you so much.
Brandon, what's the 418?
418 is the 418 HTTP status code, of which you can find RFC from the April Fool's Day RFCs, which specifies a coffee pot protocol, which responds, I am a teapot, if you ever happen to request it, of automated coffee makers. So in all of my talks, if you're paying very close attention, you will find a 418 teapot somewhere in the background as a continued joke.
Thanks, Brandon. That had about 100% more lemurs than my talks do, so that's awesome. I would also, just before we break for the evening, I would like to remind you that we do have our next Ruby meetup scheduled for June at Chime, and I'm going to look at the date, June 4th. So hopefully we'll see you all June 4th at Chime. Any more announcements, Irina, before we call it an evening?
Okay, spontaneously. I purchased sfruby.com.
Oh, wow. Just now?
No, for $25. A little bit more expensive than 14. And Yeah, there is an announcement of something happening in November in San Francisco. I'll keep it until, so you got to join our Slack to be one of the first to learn about it.
Awesome. Yep. Cool. Thank you all. We'll see you in June. Yeah.
You should tell her.